All right, people. I believe everybody is doing great, nice, and absolutely fine. So, welcome to Unacademy NEET English. Please tell me in the chats if I'm perfectly audible, visible to each and every single student. Okay? We have this beautiful chapter today that is work, power, and energy, or work, energy, and power. We'll have to complete this chapter and I am going to take, I would say, 3 hours and I'll be completing the entire chapter, all the problem patterns, whatever you have in this one. Okay? Guys, tell me in the chats, is everything going fine? Okay? That's great. That's great. So make sure you smash the like button, everybody out there, because liking the session means marking the attendance. So I would want you guys to smash the like button. Okay? I would want you guys to smash the like button because liking the session is extremely mandatory. Everybody out there, smash the like button and mark your attendance. Smash the like button and mark your attendance. Everyone means everyone. Okay? Yes. So we are going to start this particular session over here. Let's basically start the session. Let's not waste any time. Let's get started. Okay. So my dear NEET aspirants, work, energy and power. Let's first understand what is this work done. What does work done actually mean? I would want you guys to understand this very carefully. Okay. Let's see how much time it is going to take, but I'll show you all the problem patterns from the scratch, from the basics. Okay. Okay. So don't worry about that. I'll not skip anything. That is a promise. Okay. Stay till the end. Now, guys, work done. What does work done actually mean? Listen to me very carefully. Let's suppose if I say I have got a block over here. Okay. I have got a block over here. And I am applying some sort of force on this block. Let's suppose F. There is a block. I am applying some sort of force on the block. And because of this force, the block started moving and block reached this particular position. Okay. So we say block has covered some displacement. I call this S. Whenever force acts on a body, due to which it will cover some displacement, we say work has been done. We say work has been done. This is how we define work. Whenever force acts on a body and it displaces by some amount, we say work has been done. Sir, let's suppose if I have a block over here. I am pushing the block, I am applying force, but the block is not moving at all. We say in that case, work done is going to be zero. Work is, we define work only when you apply the force and some displacement is there. Okay. So when we define work done, we simply say when a force acts on a body and it displaces by some amount, we say then work is done. This is how we define work done. Now, my dear NEET aspirants, let's suppose I have got a block over here. Listen to me very carefully. Let's suppose I have got a block over here. And on this block, I am applying some sort of force, let's suppose F, at an angle of theta. And this block travels, it displaces by some distance. Let's suppose S is the displacement covered by the block. S is the displacement covered by the block. Okay. In this particular case, my dear NEET aspirants, I can say this force will have two components. If this is theta, we say this component of force will be F cos theta. Okay. And this component of force, it is going to be F sine of theta. This component of force is F cos theta and this is F sine theta. Clearly, I can say in this particular case, this F sine theta is pulling the body in the upward direction. So F cos theta is displacing the body by displacement S. So because of F cos theta, this displacement is being covered. So I say work in this particular case will be this force, that is F cos of theta, into, I would say, this displacement S. Force multiplied by displacement. When force acts on a body, it displaces by some amount. We say work is being done in that particular case. So I can say it like this also. Work is equal to W. F is F, and then we say S, and then we say cos of theta. Now, my dear friends, F cos theta, I can write it something like this. It is force dot displacement, F dot S, because AB cos theta means A dot B. So Fs cos theta means F dot S. So dot product of force and displacement is what we call work. Please tell me in the chats, is this crystalline clear till over here? Everybody out there. Come on, guys. Tell me quickly in the chats if this is crystalline clear to each and every single student. Quick, guys. And make sure everybody of you smash the like button, because smash, it means marking the attendance. Okay. Yes, that is absolutely great. That is absolutely great. So we say whenever force acts on a body and if it displaces by some amount, we say work is being done. And that work done is simply force multiplied by displacement. Which component of the force we are supposed to take? Which is going to produce the displacement here? It is F cos theta. Because F cos theta is along the displacement only. Now, my dear NEET aspirants, in this particular case, listen to me very, very, very carefully. Let's suppose I have a question over here. The question is, find the work done by external force, frictional force, mg, and normal reaction. Let's suppose you have a block over here. There are different types of forces acting on the block. We say external force is pulling the block. We say normal force upward. We say mg downward, and we say frictional force backward. And we say, sir, the block displaces by a displacement S. In this particular case, you have to tell me over here, what is the work done in this particular case? Listen to me very carefully. Sir, first of all, I would say work done by external force. Work done by external force. How do you find work done? That is force multiplied by displacement, and we say cos of theta. This is the formula. Now, in this particular case, I'll write over here external force is this, and displacement is S, and angle between force and displacement, Fs cos theta. Theta is the angle between F and S, and that is cos of 0 in this particular case. So what I can write over here, that is going to be F into S. This is the work done in this particular case due to the external force. Now, my dear NEET aspirants, if I say what is the work done by normal reaction, this normal reaction is being applied on the block by the surface. So you'll simply say, sir, normal force N, displacement is S, and what is the angle between normal force and displacement? That is 90. So I would say cos of 90. And cos 90 is 0. So work done by the normal force in this case will be 0. Let's talk about mg. Work done by mg, I'll write over here. So mg is the force, S is the displacement, and what is the angle between? We say mg and displacement, that is 90, so cos 90. So in this particular case, work done will be 0. If I say What is the work done by frictional force, my dear NEET aspirants? That is Fs cos theta. So F is the force. Okay. Displacement is S. And you see, displacement is in the forward direction, frictional forces in the backward direction. So angle between the two is 180. So cos of 180. So in this particular case, it cos 180 is minus 1. So work done is going to be minus Fs. I hope you got the crystal clear feel. I hope you got the crystal clear feel of this one. I hope you got the crystal clear feel of this one. Okay. 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 Guys, tell me in the chats, is this crystalline clear to each and every single student? And let's move on to, my dear friends, one more important point over here. What is that? See guys. We say SI unit of work is Newton meter because work is force into displacement. Okay. We say force is Newton, displacement, unit of displacement is meter. And my dear NEET aspirants, it's a scalar quantity because dot product of two vectors is a scalar. So work is a scalar quantity. And one more important point, work done does depend upon the frame of reference. Let me give you the example over here. Listen to me very carefully. Let's suppose, my dear NEET aspirants, in this particular case, I'm giving you an example over here. That is, let's suppose you have a body over here, or there is an example. Let me show you over here. This one. In this particular case, you have, or let me show you over here. You have a block. You have let's suppose there's an elevator over here. And inside the elevator, you are placing a block. And there is a person inside this, we call this as A. And there is another person over here, we call this as B. This person B is on the ground and it is at rest. This person is inside the elevator. Now, my dear NEET aspirants, if I say this elevator basically, it is going up and it is covering a displacement of h. It is going up and it is covering a displacement of h. If I say, what is the force acting on this block? Sir, force acting on this block is normal reaction. Because whenever two bodies are in contact, they apply normal force. So this surface of the elevator is going to apply the normal force on the block. My dear NEET aspirants, if I say, according to the person A, listen to me very carefully. We say according to the person A. Can I say this block is at rest? Block is at rest because this person is also inside the elevator. So the person is saying block is just next to me. Okay, I can sit on this particular block. It is not in motion. So block is at rest. So if I say work done according to person A. So according to the person A, block is at rest. So work done will be, that is force into displacement. What is force in this particular case? That is N. And displacement is 0. Okay. And then we say cos of theta. So work done in this particular case is 0. When we talk about according to the person A. Now, my dear NEET aspirants, we say according to person B. According to person B. Listen carefully. This person is saying that the elevator is going up. It has covered the displacement H. So this block also has covered the displacement H. So according to the person B, we say block has moved H displacement. Now, my dear NEET aspirants, so work done according to the person B. I can say force is normal reaction, displacement is H, and then we say cos of 0 because angle between this H displacement and normal reaction is 0. So work done in this case is N into H. So that's what I was saying. Work done does depend upon the frame of reference. If you are taking this as frame of reference, then work is 0. But if you are considering this as frame of reference, work done is not 0. Because according to this person, the block has moved a distance of h. And according to this person, block is at rest. Please tell me in the chats if this point is crystalline clear. Everyone means everyone. Please tell me in the chats if this is crystalline clear to each and every single student. Come on, guys. Quick. Quick. With the fire emojis, I need to know from every single student whosoever is watching. Come on, guys. Is this crystalline clear? Is this crystalline clear? Is this crystalline clear? Everybody out there? That's great. That's great. That's great. Now, guys, take a look. Take a look. Let's suppose you have a block over here. On this block, you are applying some force and the body is being displaced in this direction. So, angle between displacement and force is theta. And clearly, you can see this theta is less than 90. Clearly, this theta is less than 90. If theta is less than 90, what is the value of cos theta? Cos theta is going to be positive. If you check the trigonometric table, if you check the value of cos 45, if you check the value of cos 30, okay, root 3 by 2, cos 60, 1 by 2, all the values are positive. So if theta is less than 90, cos theta is positive. Then if I talk about work, it is going to be Fs cos of theta, my dear NEET aspirants. So if cos theta is positive, I can say work done in this particular case is positive. And this is what we call positive work. This is what we call positive work. Now, my dear NEET aspirants, here, if you see force acting on the block is in this direction and displacement is forward. Sir, how is it possible that the force is acting in this direction, displacement is in this direction? It may be because of some other force, na? So we are saying, let's assume force and displacement is having angle theta. And clearly here theta is greater than 90 and theta is less than 180. And if you check the trigonometric table, we say cos of theta will be negative. If cos theta is negative, can I not say work done in this particular case will come out to be negative? Absolutely, sir. 100%. Okay. Then, my dear friends, if you take a look over here, this is what we call the negative work. So from now onwards, you'll remember that if angle between force and displacement is greater than 90, less than 180, in that case, cos theta will be negative, work will be negative. If angle between force and displacement is less than 90, sorry, if it is greater than 90, work will be negative. If it is less than 90, work will be positive. And if we say angle between force and displacement is 90, in this particular case, what is the value of cos 90? That will be 0. And in this case, work done is going to be F into S. Then we say cos of 90. Cos 90 is 0. So work done in this case will be 0. So this is what we call 0 work. So when the displacement and force are perpendicular to each other, then work in that particular case is negative. Okay. Let's solve some questions. Let's first move on to the question. This was asked in NEET 2016. Take a look, my dear NEET aspirants. Take a look, my dear NEET aspirants. A particle moves from point A. This is the point A. This is the point A. And its position vector is given. That is R1 is equal to, I would say this is minus 2i cap plus I would say 5j cap. To point to another point. This is another point. Its position vector is given. So I would say its position vector is given as that is 4j cap. Then we say plus 3k cap. Okay. Yes. Now, my dear NEET aspirants, listen to me very carefully. When a force of, and force is also given in the vector form, when a force of, I would say 4i cap plus 3j cap acts on the body, we are supposed to find the work done. Guys, listen to me very, very, very carefully. If the question comes out to be something like this, you have one point, its position vector is given. You can understand it like this. These are the coordinates of this point. These are the coordinates of this point. X coordinate is 4, Y coordinate is 3. X coordinate is -2, Y coordinate is 4. And how do we find the work done? Guys, we say work done is F vector dot S vector. Listen carefully. If the question is given in the vector form, so we'll prefer to use the vector form now. Force dot displacement dot product of two. But what is displacement over here? Listen, we say join the 2 points. This is going to be the displacement. This is the displacement. And always remember, displacement is final position minus initial position. This is R2. So you'll be writing over here R2 minus R1. So from now onwards, if it is given a particle moves from this point to that point, displacement is going to be final position minus initial position. Now, my dear NEET aspirants, what will you say? So this position vector you'll be writing over here R2 minus R1. What is the value of R2? You can say over here this is 4j cap. I would say plus 3k cap. Okay. Then minus R1. Then minus this. So I would write over here this is minus 2i cap. And then I would say plus 5j cap. Listen carefully, guys. So I can say this is 4j cap plus 3k cap. Now see, minus into minus is plus 2i cap, and then minus into plus is minus, and this will be 5j cap. Now listen carefully, my dear NEET aspirants. What can I write over here? This is 4j and this is 5j. 4j minus 5j. 4j minus 5j. Yes, this is 4j and then minus 5j. This is going to be minus j cap. And here it is 2i cap, then minus j cap, and then we say 3k cap. This is going to be the displacement vector in this particular case. Now, if it is the displacement vector in this particular case, my dear NEET aspirants, now you'll say work is equal to F dot S. So work is equal to force dot displacement. So force vector in this particular case is 4j I cap plus we say 3j cap. And dot product we are supposed to do with displacement. Displacement vector is, I would say, 2i cap minus j cap plus 3k cap. This is the displacement vector. Now, my dear NEET aspirants, what can I say further? See guys, how do we do the dot product? How do we do the dot product? Okay. How do we do the dot product in this particular case? We say this is 4 into 2 is, I would say 8. I with I, whatever is the coefficient of I, multiply with I. 4 into 2 is 8. Then we say this j with this j. So in this particular case, 3 into 1 is minus 3 over here. And then what is the coefficient of k over here? That is 0. That is 0. And then in this particular case, 0 into 3, this is going to be 0. So work in this case is 8 minus 3 is, that is 5 joules. Guys, tell me, is this clear? Please tell me in the chats. Is this clear? Everybody out there, is this clear? Is this clear? Give me the signal in the chats with the fire emojis if this is crystalline clear. If this is crystalline clear. Is this crystalline clear? Now, my dear NEET aspirants, let's talk about this particular question. This was the question asked in NEET 2014. See guys, a uniform force of 3i cap plus j cap Newton acts on a particle of mass 2 kg. Okay. So force in this particular case is given as, listen carefully, that is 3i cap plus I would say j cap. Hence, the particle is displaced from the position this to this position. So particle is displaced from this position. So R1 in this particular case is given as, I would say 2i cap plus k cap. Okay. To the position, this position, and its position vector in this particular case is given as, that is 4i cap plus 3j cap minus I would say k cap. Now in this particular case, can I say Sir, when it comes to the displacement vector, this is going to be the displacement vector between the two. And how do we find the displacement vector? That is R2 minus, I would say, R1 vector over here. Okay. Now, what is the value of displacement vector in this particular case? R2 minus R1. Guys, see, here it is 4i. 4 minus 2 is, I would say, 2i. So, I minus I, that's what you guys are supposed to do. And then you have 3j. Here you have nothing, 0j. So, 3 minus 0, that is going to be 3. And this is going to be plus 3j cap. And then, my dear NEET aspirants, you have minus k. Here you have plus k. So what will you say? Sir, minus 1, because this is minus k. And then this minus 1, minus k, minus k. So that is going to be minus 2k. This is minus 2k cap. This is going to be the displacement vector in this particular case. Now, you know the force, you know the displacement. So how can you find the work done? That is force F dot, I would say, S. So work done in this particular case, dot product of F and S. So what is the value of force? That is 3i cap plus, I would say, j cap. Dot product with, that is 2i cap plus 3j cap minus 2k cap. You can write it like this. Now, how you guys are supposed to do the dot product in this particular case? I would say I with I. This 3 into 2 is 6. This is how do we do the dot product. 3 into 2 is 6. Okay. Then plus. Coefficient of this is 1. Coefficient of this is 3. So 1 into 3 is, I would say, 3. Sir, are we supposed to write I cap over here? No. And then we say over here it is 0 and it is over here 2. So 0 into 2 is 0. So work done in this particular case is 9 joules. Is this clear? Is this clear? Tell me in the chats, everybody out there. Tell me in the chats, everybody out there. Is this clear? Is this clear? Quickly, guys. Okay. Now, guys, take a look. Take a look in this particular case. Take a look at this particular question over here. Take a look at this particular question over here. Okay. Now, guys, take a look. Listen to me very, very, very carefully. A rope is used to lower a block vertically of mass m by a distance x. Listen, guys. You have got a block over here. You have got a block over here. And there is a rope connected to this block. There is a rope connected to this block. Okay. And when you are connecting a rope with a block, now you are lowering the block. Okay. You are lowering the block. This is how do we lower a block. You are connecting a rope. This is a block and you are lowering the block. Okay. So the block is coming down by a distance of, I would say, x. So the block is coming down by a distance of x. And tension in this rope, I would say, is T. Okay. With a constant downward acceleration. Acceleration of this block in this particular case is given as G divided by 2. And what is the force acting in the downward direction? That is M into G. Now, in this particular case, the questioner says that the work done by the rope on the block is. So we have, when it says what is the work done by the rope, means we have to find work done by tension. So I'll write over here to find work done by tension. Okay. Now, how do we find the work done by tension? Sir, simple. Work done in this particular case will be Fs cos of theta. So work done in this particular case will be, what is the force? That is tension. And what is the displacement it is doing? That is x. And cos of, I would say, 180. Why? Because tension is upward, displacement is downward. That's why cos 180. So work done will be minus t into x. Now, guys, in this particular case, tension is not given in the question. So we are supposed to find the value of tension. I'll just write over here, let's find tension. Let's find tension. How do we find tension? Use Newton's second law. We say net force is equal to mass into acceleration. Now, guys, see, if the block is going down with acceleration g by 2, we say net force is equal to mass into acceleration. So net force is mg is downward, tension is upward. So net force is going to be mg minus t is equal to mass into acceleration. What is acceleration? That is g divided by 2, my dear NEET aspirants. Now, if you take it over here, so this is going to be mg minus, I would say, mg divided by 2 will come out to be tension. mg minus mg by 2, it is going to be mg divided by 2 will come out to be tension. So you got the value of tension. Now put it over here. Put it over here. So work done in this particular case is minus. What is the value of tension? That is mg divided by 2 into, I would say, x. This is the answer to the question. This is the answer to the question. So basically, a rope was attached to the block and it was lowering down. It was going down. We were supposed to find the work done due to the tension. I hope this is crystalline clear. I hope this is crystalline clear. Let's move on to this particular question. Let's move on to this particular question. Calculate the work done to move a body of mass 10 kg along a smooth inclined plane. There is a smooth inclined plane. Listen to me very carefully. There is a smooth inclined plane. Smooth means no friction. Okay. And this angle is given as 30 degrees. Now it says in this particular case, calculate the work done to move a mass of 10 kg along a smooth inclined plane with a constant velocity through a distance of 10 meters. Through a distance of 10 meters. Let's suppose this is the block over here. This is the block over here. This is the block over here. Now, guys, what is the force acting on this block in the direction, in the downward direction, mg? And if this is 30, or we said this will be also 30 degrees. If this is theta, this is theta. So this component is going to be mg cos theta. And this component is going to be, that is mg sin theta. This component. Now, my dear NEET aspirants, in this particular case, we say work is being done. If the block is going down the inclined plane, in this particular case, we say work is being done due to which force? I would say mg sin theta, not mg cos theta, because mg cos theta is perpendicular to the displacement in this particular case. So we say here, work is being done by mg sin theta. So how much is the displacement? How much is the displacement? I would say 10 meters. Displacement is 10 meters. So what can I write in this particular case, my dear NEET aspirants? You say simply work done is, that is force S, and then we say cos theta. Listen carefully. So work done is, what is the force I'm supposed to take? Mg sin theta, and theta is 30. So I'll just write over here, this is mg sine of 30 degrees. Okay. And then displacement is S. So I'll write over here S, and then cos of theta. Now, my dear friends, this point is important. What is the angle between this force mg sin theta and displacement? That is 0, because they are parallel to each other. Because it is going down. So this is the displacement along this inclined plane only. So I would say cos of 0. This point is very important. Now I can say work done in this particular case. What is the value of mass of this object? That is 10. Acceleration due to gravity is 10. Sin 30 is 1 by 2. This is also 10. Cos 0 is 1. Now, guys, 2 1s are 2 5s are 10. So 10 in 10 is 100. 100 into 5 is 500. So work done in this particular case is 500 joule. Please tell me in the chats if this is clear. Please tell me in the chats if this is clear. Come on, guys. Tell me in the chats if this is crystalline clear to each and every single student. And smash the like button if you have not liked the session yet, because liking the session is extremely mandatory. Tell me in the chats with the fire emojis if this is crystal clear to each and every single student. So till now we were studying work done by the constant force. Now let's move on to the work done by variable force. Let's move on to the work done by variable force. See guys, let's move on to the work done by variable force. Understand this very carefully. There is nothing much in this one. Oh, it's simple. Here, this is a block. You have to find the work done on this block when it displaces by displacement 10. So we say you have to find out what is the force acting. In the downward direction, it is mg. So in this direction, it is going to be mg sine theta. In this direction, it is going to be mg cos theta. This is not going to do work. Why? Because this is making the angle of 90 degrees with displacement. So there is only one force which is going to perform work, that is mg sine theta. That's why instead of force, I'm writing mg sine theta, displacement, and then cos 0. Why cos 0? Because angle between this force and displacement is 0. Work done by variable force. See guys, let's suppose you have a block over here and you are applying a force of F is equal to 10 Newton on the block. This 10 Newton means constant force. This 10 Newton means constant force. Okay. This 10 Newton means constant force. Now, my dear NEET aspirants, if I, let's suppose, say there is a block over here, and on this block, I am applying the force F is equal to, I would say, 2x. This force, is this constant or variable? Sir, this is variable. Why? Because it depends upon x. It depends upon x. When the value of, now listen to me very carefully, when the value of x is 1, we say force is going to be 2 into 1 is 2 Newton. When the value of x is 2, means after 2 meters, force is going to be 4 Newton. When the value of x is 3, we say force is going to be, I would say 3 into 2 is 6 Newton. Okay. Now, my dear NEET aspirants, in this particular case, if you are applying this force on this block, we say this block is going to move and it will reach, let's suppose, this point. Listen to me very carefully. I say, sir, what am I supposed? If I say, what is the work done over here? You say, sir, work done is Fs cos of theta. Okay. Now, displacement, let's suppose it is doing, let's suppose 10 meters. Displacement S is equal to 10 meters. What are you going to put the value of force over here? Sir, will you put 2? Will you put 4? Will you put 6? Because force has different values during the entire journey. So in this particular case, what you are going to do is, you'll basically consider a small displacement. You'll consider a small displacement, that is ds. And on this small displacement, I can say force will be, let's suppose, F. Okay. So in this particular case, we say here force is variable. Let's suppose this is point A and this is point B. From A to B. So we cannot use Fs cos theta directly. Why? Because what am I supposed to put the value of force in that particular case? That's the reason I am saying, my dear NEET aspirants, what you guys are supposed to do is you consider a small displacement. So let's find work done in small displacement. Let's find work done in small displacement. So small displacement over here is ds. So for this small displacement, I can say force will be constant. I see. If you move from this point to this point, force is variable. But at a particular point, force will be constant. So we say, let's find the work done in a small displacement. Because in small displacement, at a particular instant, force is going to be constant. So that work done is going to be dW. Okay. Because if I say, sir, in this small displacement, if a body displaces by little amount, How much work is being done? Small. So this dW is simply going to be F and then ds. Force multiplied by small displacement. Sir, can we use this? And what is the angle? Angle is cos of 0 because force and displacement are in the same direction. Now, this is the small work done. In order to find the total work done, to find total work done, total work done, what I'm gonna do is I'll do the integration. So integration of dW is equal to integration of F and then we say ds. So we say this integration of dW is going to give you the total work done. It is integration of F and then we say ds. I hope you got the crystal clear feel. This is how we are supposed to find the work done in variable force. Sir, can't we use Fs cos theta directly when the force is variable? No, that is for the constant force. Because from A to B, if force is changing, you'll be considering small displacement. So for this small displacement, force is constant. So we can use this formula. Okay, but work done is going to be small. Then to find the total displacement, you'll do the integration. I hope this is crystal clear to each and every single student. Guys, tell me in the chats. Let's move on to the question. And this question is going to give you the crystal clear feel. A force F is equal to kx square. Force is acting on an object, that is kx square. Now you clearly see, is this force variable or constant? Is this force variable or constant? This is variable. Why? Because it depends upon x. This is variable force. If I say value of force is 10, 20, 30, 40, it means constant. But in this case, we say force is variable. Now, my dear NEET aspirants, we are supposed to find a force F is equal to k times of x acts on a particle at an angle of 60 degrees. With the x-axis, the work done in displacing the particle from x1 to x2 is, we are supposed to find the work done in displacing the particle from x1 to x2. Now guys see. Can I say in this particular case, listen carefully, my dear NEET aspirants. Listen carefully, my dear NEET aspirants. So how do we apply the force? Sir, that is F dot ds or F dot ds. And I can say over here, don't write 0 degree over here. Let's generalize it, write theta. And you can write, sir, cos theta, F ds cos theta, F ds cos theta. You can write it like this. Even you can say W is equal to integration of F dot ds. Okay, now my dear NEET aspirants, you can write it over here. So W is equal to integration of F, then we say ds, and here it is given in terms of x. So I'll write F dx, and then we say cos of theta. Okay, now guys, work done in this particular case will be F. What is F? That is k x square instead of F. And then we say dx. And what is the angle given over here? That is 60 degrees, because the question says it is acting at an angle of 60 degrees. Okay, there is a block. On this block, force F is acting at an angle of, I would say, how much? 60 degrees with x-axis. Now guys, this work done I can write over here. Cos 60 is 1 by 2. Okay. So take that 1 by 2 out, k out. So k out and 1 by 2 out. That is k by 2. Then you have got over here x square. Integration of x square is x cube divided by 3. How do you do the integration? Power plus 1 upon power plus 1. And it says from x1 to x2. So if it says from x1 to x2, first limit is x1 and second limit is x2. So here it is x1 and here it is x2. Okay. Then my dear NEET aspirants, what will you say? Work done is going to be 3 into 2 is 6. So this will be k divided by 6. And then x cube. First you need to put the upper limit, then minus lower limit. So that is going to be x2 whole cube minus x1 whole cube. I hope this is crystal and clear to each and every single student. Guys, tell me in the chats if you got the feel of this question. Tell me quickly. Is this clear, my dear NEET aspirants? Guys, smash the like button and mark your attendance because marking the attendance is very mandatory. Okay, let's move on to the next question. That is this one. A force F is equal to 20 plus 10y. Force F is equal to 20 plus 10y. F is equal to 20 plus 10y. Now tell me, is this force variable or constant? This is variable. Okay, is this variable? Now, my dear NEET aspirants, now hey, it is not sine theta over here. It is value of cos theta is given. Okay, when you have value of, it is not cos theta. It is cos 60. So you need to put the value of cos 60 over here. Now guys, F is equal to 20 plus 10y. This force in this particular case is variable. Okay, this is variable. Now, my dear NEET aspirants, what you guys are supposed to do over here is, you have to find this is the force acting on the particle in y direction. There is a particle, force is acting on this particle in y direction. Okay, where F is in Newton and y is in meters. Work done by this force to move the particle from y is equal to 0 to y is equal to 1 meters. So this particle moves from y is equal to 0 to, I would say, here, and here y is equal to 1 meters. We are supposed to find the work done. So what can I say? Sir, work done in this particular case will be integration of, you can say, force dot displacement F, and I'll write over here dy, because it is not along x, it is along y. So this is along y, F dot dy, and then we say cos of, in this particular case, that is 0. F dy, and then we say cos of 0. Why? Because the force is acting in the y direction and displacement is also in the y direction, so angle is 0. So work done in this particular case will be integration. And you need to put the limits also, my dear NEET aspirants. You need to put the limits also. See? So it says from y is equal to 0 to 1. So it is going to be 0 and it is going to be 1. So work done in this particular case will be integration of, what is the value of force? That is 20 plus, I would say, 10y. And then you will be writing over here dy, and cos 0 is 1. So from 0 to 1. So then you will be writing over here, this work done is going to be in this particular case. Okay. It is going to be, I would say, what is that integration of 20? So it is going to be 20y. And then what is the integration of 10? It is going to be 10y square divided by 2. Okay, because with respect to dy we are doing from 0 to 1. Okay, now guys, work done in this particular cases. So 20y, so this is 20. Then put the upper, in this y you need to put the upper limit, that is 1, minus lower limit 0. Then over here plus. So this is 2 1s are 2 5s are 10. I can write it over here. 2 1s are 2 5s are 10. So this is 5y square. So this is 5. And then in this y square, you need to put upper limit minus lower limit. Upper limit is 1, minus lower limit is 0. So now work done in this particular cases, this is 20 and this is plus 5. That is going to be 25 joules. Is this clear? Tell me, guys. 25 joules is the correct answer in this particular case. Area under force displacement graph. Guys, give me the signal in the chat if this is crystalline clear. Tell me quickly. Area under force displacement graph. Area under force displacement graph. Listen carefully. Let's suppose you have force versus displacement. And this is the graph. This is the graph, this curve. And you need to find area under this graph. That is this area. This area. Now guys, see, I have told you this so many times. If you have y versus x graph, okay, and if I asked you to tell me area under this y versus x graph, you will be simply saying it is integration of whatever is on y-axis, write it over here, and whatever is on x-axis, write it over here, dx. Y dx, integration of y dx. This is in case of y versus x graph. In case of f into s graph, I can say area is going to be integration of whatever is on y-axis, that is f, and whatever is on x-axis, that is ds. This is going to be the area. Now guys, recently you studied, what did you study? You studied as work done is equal to integration of f into ds. Okay. Now, if you say, sir, this is equation first, if you say, sir, this is equation second, you see right hand side is exactly matching. So can I not say area will be the work done? So I can say this area is going to give us the work done. This area is going to give us the work done. In which graph? I would say in case of force versus displacement graph. In case of, I would say FS graph. In case of FS graph. Okay, in case of FS graph. Now, let's take a look at this question. So from now onwards, if force versus displacement graph is given and you are supposed to find work done, what will you find? Area. In this particular case, a position dependent force F is acting on a particle and its force position curve is shown in the figure. Then work done on the particle from 0 to 5 is. See guys, force versus displacement is given. We are supposed to find the work done from 0 to 5. If force versus S graph is given, you are supposed to find work done. So what will you find? Area. So work done in this particular case, that is going to be area. As simple as that. Now you tell me area. Guys, that is area of this triangle. Let me just mark it over here. That means area of this triangle, area of this rectangle, area of this triangle, and this rectangle. Now see guys. If I say area, first you need to find the area of this triangle. That is 1 by 2, base is 1 and altitude is 10. 1 by 2, base is 1, altitude is 10. Then area of this rectangle, that is length, 2 minus 1, this is 1, breadth is 10. So that is 1 into 10 plus 1 into 10. Then area of this triangle, okay, it is again, I can say, plus area of that triangle is 1 by 2, base is 1 and altitude is 10. Area of this triangle. Then minus area of this triangle. Why minus? Because it is from the lower side. Okay, not from the upper side, from the lower side. So it is 1 by 2. Its base, 4 minus 3 is 1 and base is 10. So that is 1 and this base is 10. And then my dear NEET aspirants, if I say this area of this rectangle, that is length in this particular case is 10 and breadth is 1. 5 minus 4 is 1. So that is again 1 into, I would say, 10. 1 into, I would say, 10. I hope this is crystalline clear. Guys, tell me in the chats quickly, is this crystalline clear? So what I can say over here, this plus 10, this minus 10. Okay. This 1 by 2 into 10, this 1 by 2 into 10. 2 ones are, 2 5s are. So work done in this particular case came out to be 5 joules. That is 5 joules. So from now onwards, if you have force versus displacement graph and you are supposed to find work done, what will you find? You will find simply, I would say what? That's area. Now you have this particular question in this particular case, okay? Force versus displacement graph is shown. The work done by the particle during the displacement of 12 meters. So graph is from here to here. This is the actual graph. This is the actual graph. This is the actual graph. So means you have to find this area. So in this particular case, if I say work done, that is going to be area, and that is going to be area of the square. Guys, 7 minus 3, that is 4. And breadth is 2. 4 into 2, that is 8. Then plus area of this 1 by 2. What is base? 12 minus 7, that is 5. And this height is, I would say, 2. This height is 2. Now this and this will cancel. 4 2s are 8, and this will come out to be 13 joules. This 13 joules. No. It is from here. Graph is from here to here in this particular case. Okay. You can understand it like this. For first 3 meters, force is 0. For first 3 meters, force is 0. Okay. This question, again the same question. Let's solve this. We have solved one pattern of this question already. A bucket of mass m tied to a light rope. A bucket of mass m tied to a light rope is lowered with a constant acceleration g by 4. Guys, see. This is the bucket that you have. This is the bucket that you have. Okay. This is the bucket that you have. Okay. And it is connected to a light rope, and tension is in the light rope. It says it is lowered, okay, with an acceleration g by 4. So acceleration is given as g divided by 4, and it is lowered means it is going down. If the bucket is lowered by a distance d, it is going down by a distance d. It is lowered by a distance d. And what is the force acting in the downward direction? That is going to be m into g. Okay. The work done by the rope will be, we are supposed to find work done by the tension. Again, the same question. Work done is going to be tension. Work done is going to be Fs, and then we say cos of theta. And work done is going to be force, in this case is tension. And displacement is, I would say, d. And what is the angle between tension and displacement? Displacement is downwards. So I would say cos of 180. Cos of 180. So work done in this case will be minus t into d. Minus t into d. Now, my dear NEET aspirants, what I can say in this particular case, listen to me very carefully. You have to find tension. Let's find tension. Let's find tension. Let's find tension. So we'll use Newton's second law. So I can say net force is equal to mass into acceleration. Net force means if the acceleration is downward, so net force is going to be downward. So net force means this mg minus upward is t is equal to mass into acceleration. It is going down with what acceleration? G by 4. So this is going to be g divided by 4. Now take this tension over here and this over here. This will be mg minus, I would say, mg divided by 4 is equal to t. So 4 mg minus mg, this will be 3 mg divided by 4 is going to be t. So this tension, now put it over here. Work done is going to be minus, this will be 3 mg divided by 4. And we say, sir, d. I hope this is crystalline clear. I hope this is crystalline clear to each and every single thing. I hope this is crystalline clear. Guys, is this clear? Tell me in the chats. Tell me in the chats. Everybody out there. And make sure everybody of you smash the like button. Okay. Now, guys, let's talk about work done by gravity. See, guys, work done by gravity. Listen carefully. Let's suppose there is an object. It is moving by a displacement of s. mg is gravity is acting downwards. In this particular case, if I say what is work done by mg, that will be force is mg, displacement is s, and what is the angle between the two? That is 90. So work done by mg in this particular case is 0. Work done by mg in this particular case is 0. If I say what is the work done here? Body moving downwards, this body is lowering down. So in this particular case, work done, I would say, due to mg is simply force is mg and displacement it is doing h. Angle between the two is 0, so cos of 0. So you can simply say work done in this particular case is mg into h. Okay. Now, my dear NEET aspirants, if I say in this one, this body is going up, mg is acting downwards, body moving upwards. So work done in this case, just a second. See, guys, in this particular case, you say work done due to this mg. It will be force is mg, displacement is h, and mg is acting downwards. If it is going up, so angle is 180, cos of 180. So work done due to mg in this particular case is minus mg into h. Okay. In this particular case, guys, if the body is going down something like this, what is the vertical displacement covered by the body? That is h. So here also work done is going to be mg into, I would say, sir, h. mg into h. Because vertical displacement here is, that is h. Vertical displacement is h. Now, boys and girls, listen to me very carefully. In this particular case, it is mgh. In this particular case, it is mgh. In this particular case, it is mgh. So can I say, sir, work done by the gravity does not depend upon the path? Let me give you one more example that will make you understand. See, guys, if this object is released, it is falling down. So what is the work done in this particular case? That is mg is force h, mg into h. This body goes up, then it comes down. So what is the displacement covered? What is the displacement covered? That is h only. No doubt it is going h, it is going up. But displacement means join initial and final point. Join initial and final point. So in this particular case, work done is mg into h. Okay. And if it is thrown downwards, so in this particular case, it is mgh. This was released, this is thrown downwards. Now, if this object goes something like this, but how much is the vertical displacement from the ground? That is h. So here also, this is going to be mgh. Object in reality is following this path, but what is the displacement from the surface to that point? Join initial and final point, that is h, mgh. Here also mgh, here also mgh, here also mgh. So can I say in this particular case, guys, here path is this, here path is this. So can I say work done in all the cases due to gravity is mgh? So can I say work done by gravity does not depend upon the path. Work done by gravity does not depend upon the path. Okay? Work done by gravity does not depend upon the path. And this is what we call the conservative force, in which work done does not depend upon the path. So we call this as conservative force. Conservative force. So this much you need to remember in this particular case. Okay. Okay. So work done due to gravity does not depend upon the path. I hope this, and this is what we call the conservative force. This is what we call the conservative force. Now, guys, let's move on to work done by spring. Guys, give me the signal in the chat. Is this crystal and clear to each and every single student? Come on, tell me quickly in the chats. Tell me quickly in the chats. Okay, that's great. Work done by spring. Listen to me very carefully. Let's suppose, my dear NEET aspirants, you have got a spring over here. This is a spring. And there is a block connected to the spring. There is a block connected to the spring. Listen carefully. Let's suppose if you elongate this spring and if you take the block till over here, by applying which force? By applying, I would say, external force. There is a spring, there is a block connected to the spring. You are elongating the spring by applying the external force. We know that this spring is going to create the restoring force. This is a restoring force, or I would say Fs, force due to the spring. And this force, everybody knows that this is minus k times of x. This force is minus k times of x. So if you elongate the spring, it will create the restoring force, which will try to pull back this block. So that force is equal to minus k times of x. K is what we call the spring constant. And x is the displacement that you have displaced this block. Okay. Now, if I say work done in this particular case, listen to me very carefully, my dear NEET aspirants. When I say work done, we say as. Let's find work done by spring force. Let's find work done by spring force. Spring force. Let's find work done by spring force. So what I can say in this particular case, work done is simply going to be integration of F and then we say dx. F and then we say dx. Okay. Now, my dear NEET aspirants, tell me one thing. If you write over here F and dx, so what is the force you guys are supposed to consider over here? You have to find the work done due to the spring force. So in this particular case, you will be considering the spring force only. You will be putting the value of spring force only. That is k times of x. Okay. That is k times of x. Now, my dear NEET aspirants, so what I can do in this particular case, so displacement is done in this direction. Listen to me very carefully. And restoring force is acting in the opposite direction. So you'll be putting over here cos of 180 also. So this work done in this particular case will be cos 180 is minus 1. Take that minus out. So this will be F and then we say dx. And let's suppose here displacement is x1. So here it is x final, x initial, x final. This is the initial position, final position. So what I can write in this particular case is, sir, this work done is going to be minus, then integration of. What is the value of force? That is k times of x. Magnitude of force. Sir, this minus, this negative sign is actually, if the displacement is done in this direction, restoring force will be opposite. So you don't have to take once again this. So write k times of x only and then we say dx. Then what you are going to write in this particular case, sir, work done in this particular case will be, that is minus and then take this k out. Then we say integration of x. What is the integration of x? It is going to be x square divided by 2. And limit will be from x initial to x final. So this is x initial and this is x final. So my dear NEET aspirants, so this will be X initial and this will be X final. So what will you further do in this particular case? This W is going to be minus 1 divided by 2. Then we say K. Then in this X, you need to put this upper limit, that is X final square minus, I would say, X initial square. This is going to be the work done in this particular case. This is the work done by the spring force. This is the work done by the spring force in this particular case. Okay. 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 And one more important thing I just want to tell you in this particular case. Listen, guys, carefully. Listen, guys, carefully. Listen, guys, carefully. That is, if you elongate the spring, we say work done in that case is negative. We say work done in elongation is negative. Even if you compress the spring, restoring force will be outward. See guys, these are the two different cases. If I say this is a spring, if you compress the spring, this is X, so restoring force will be outwards. Here also, if you find the work done, angle between this and this is 180, here also work done is going to be negative. So if I say work done in compression, work done in compression is also, I would say, negative. Work done in compression is also negative. Now, one thing I just want to mention over here. See guys. Let's suppose this is the spring over here. This is the block. Now, this is the block. This is the mean position. This is what we call mean position, where the block is in equilibrium at rest. This is what we call extreme position. Now, guys, see, when the block is coming back from extreme to mean, in that case, this is the restoring force towards mean. Restoring force is always towards the mean position. And in that case, this is going to be X. So we say here, angle between force and displacement is 0. We say work done from extreme to mean is positive. Why? Because angle between this and this is 0 degrees. That's what I can say in this particular case. I hope this point is crystal and clear, because this is an important point which I want to tell you in this particular case. Why? Because here in this particular case, we say theta is equal to 0 degrees. Okay, in this particular case, you can say theta is equal to 180 degrees over here. That's why we got negative work. Okay, when you are elongating from the mean position and when you are compressing from the mean position, we say from the mean position, from mean to extreme, from mean to extreme. Okay. I hope this is crystal clear to each and every single student. Let's move on to this question. See, guys, the question is, if work done by the spring is W in elongation of 2 meters, then find the work done in further elongation of 2 meters. See guys, you have elongated a block. Let's suppose from this point to this point. You have elongated the spring from this point to this point. We say X initial is 0 and X final is 2 meters, because it says work done in elongating the spring from 0 to 2 meters is W. Let's find this work done. This work done is going to be minus 1 divided by 2K. X final minus X initial square. X final square minus X initial square. Because this is how we find the work done. No? 1 by 2K X final minus X initial square. So in this particular case, this is minus 1 by 2k. What is x final? X final is 2 square. So 2 square is 4 minus initial is 0. So 2 ones are, 2 twos are. So work done in this particular case will be minus 2k. Okay. Then it says, then find the work done in further elongation of 2 meters. Guys. Then you further elongate it to 2 meters. So what is going to be the value of x final over here in this particular case? So I'll make it the next case. So further when you elongate the 2 meters, so x initial will be here 2, further 2, so x final in this case will be 4 meters. So if I ask you in this particular case, tell me the work done. What are you going to do? Sir, work done in this particular case will be minus 1 divided by 2. Then we say k, x final minus x initial square. Final is 4 square minus initial is 2 square. So work done in this particular case is 1 divided by 2 k. This will be 16 minus, I would say, 4. So work done in this particular case will be minus k divided by 2. 16 minus 4 is, I would say, 12. So 2 ones are, 2 6 are. So this is 6k. W is equal to minus. This is 6k. I can write this as minus. I can write this as 3 into minus 2k. Now see, 3 into 2 is 6, so it is minus 6k. Now what is minus 2k? That is W. Let's call this as W dash. So this W dash will be 3 into minus 2k is W. So this will be W. So answer is 3W. Answer is 3W. I hope this is crystal and clear to each and every single student. I hope this is crystal and clear to each and every single student. The force constant of a wire is K and another wire is 2K and that of another wire is 2K. You have force constant means spring constant. Spring constant is K. Okay. And another wire is having 2K. Both wires are stretched by same distance. Guys, see. You have two springs. Wire means spring. So this is the spring. This is another spring. It says this is elongated by the same distance. So elongation in both is same. So let's suppose here it is elongated by 2 meters. This is also elongated by 2 meters. So elongation in both is same. Okay. And the force constant of wire K1 is given as K. So value of K1 is given as K. This has spring constant K. So K2 is given as 2K. This has spring constant 2K. When both wires are stretched by same distance, then the work done will be. We are supposed to find the work done. Guys, see. How do we find the work done? Minus 1 by 2 K. Then I would say x final minus x initial. X final minus x initial. It's square. What is this? This is actually delta x. So delta x in this particular case is constant. So what I can say in this particular case, I can say this W is proportional to, I would say, K. This W is proportional to K. So can I not say in this particular case, that is work done in first W1 divided by W2, it is going to be, that is K1 divided by K2. W1 by W2 is K1 divided by K2. Okay. So I can say this W1 in this particular case divided by W2. Okay, it is going to be K1 is K divided by, I would say, 2K. Okay. So this and this will cancel, take it over there. So W2 will be equals to 2 times of W. Okay. Now, let's move on to this one, my dear NEET aspirants. Let's move on to this one. That is kinetic energy. Let's move on to the kinetic energy. Okay. Now tell me, guys, what is this kinetic energy all about? What does kinetic energy actually mean? See, guys, let's suppose you have, let's suppose you have an object over here. Its mass is m and its velocity is v. Whenever there is an object which is in motion, we say it has one energy associated with it. That is what we call kinetic energy. We say that energy, I would say that energy which is due to the motion of an object. That energy which is due to the motion of an object, that is what we call kinetic energy. That energy which is due to the motion of an object, that is what we call kinetic energy. And when I say, just a second, guys. Just a second, guys. Just a second, guys. There is a power cut. Just a second, guys. Just a second, guys. There was a power cut. How many Kashmiris in the chat? Give me thumbs up. I need to see. Okay. So you have this kinetic energy. It is that energy which is due to the motion of an object. That is what we call the kinetic energy. Okay. That energy which is due to the motion of an object, that's what we call. So if there is an object, it has mass, it has velocity, it will have kinetic energy. And how much is this kinetic energy? We say this kinetic energy is simply 1 by 2 mv square. This kinetic energy is simply 1 by 2 mv square. This is the value of kinetic energy. Okay. Now, my dear NEET aspirants, what I want you guys to understand in this particular case, that is, we say multiply this equation with m and divide with m. So kinetic energy will come out to be 1 by 2 mv square. You multiply with m and you divide with m. So this kinetic energy is equal to m into m is how much? M square. And then we say v square upon, and then we say 2m over here. Then we say 2m over here. Now, my dear NEET aspirants, I can say take this over here. So this will be and tell me, what is the value of momentum? You guys know momentum is mass into velocity. So can I say this kinetic energy is going to be, this will be over here p square divided by, I would say 2m. This is p square divided by 2m. This kinetic energy will be p square by 2. So can I write from this also, if you take it over here? So this momentum, so if I write this momentum over here, so momentum will be this 2m you can take over here. This will be 2m. This will be over here. Momentum will come out to be, that is 2m. And then we say kinetic energy. And instead of this square, you can put the root over here. So you can write it like this also. You can write it like this also. Okay. Yes, absolutely, sir. Absolutely, sir. So we can say this is the relation between momentum and kinetic energy. Now, guys, listen carefully. You have two equations. First is this one, and second is this one. And one more important thing, in this one, this v is actually speed. This v is not velocity. Keep that thing in your mind. This v is speed. And this kinetic energy is a scalar quantity. It's a scalar quantity. Now, if I say you have two equations over here for kinetic energy. Kinetic energy is 1 by 2 mv square. Okay. And second one is kinetic energy is equal to, I would say, p square divided by 2m. Kinetic energy is p square by 2m. My dear NEET aspirants, if I say, if velocity of a body is constant, then we say this kinetic energy is directly proportional to mass. If this is constant, we say kinetic energy is directly proportional to mass. And if I say momentum of a body is constant, in that case, I can say kinetic energy is inversely proportional to mass. You can completely understand it like this. Okay. So if I make the graph between, I would say, if I make the graph over here, between what? Between kinetic energy and mass. So I would say between kinetic energy and mass, it is going to be the straight line. And in this particular case, if I make the graph between, I would say kinetic energy and mass, it is going to be a rectangular hyperbola because it is inversely proportional to mass. It is inversely proportional to mass. Okay. So you have to understand, you have to see this in the question. If velocity is given as constant, so kinetic energy and mass has direct relation. If momentum is given as constant, then kinetic energy and mass has inverse relation. Keep that thing in your mind. Let's take a look at this question. Two bodies with same kinetic energy are in the ratio of, two bodies with kinetic energy is in the ratio of, you have got two bodies, kinetic energy ratio K1 divided by K2 is 4:1. Are moving with equal linear momentum. In this case, linear momentum is given as constant. Momentum is given as constant. Then the ratio of their mass is, guys, when momentum is constant, what is the relation between kinetic energy and mass? Inverse. So we say if momentum is constant, we say kinetic energy is inversely proportional to mass. So can I say kinetic energy of first object divided by kinetic energy of second object? It will be, guys, if it is inverse relation, so it is going to be mass of second divided by mass of first, m2 divided by m. If this was direct relation, I would have mentioned over here kinetic energy of first divided by kinetic energy of second is mass of first divided by mass of second. I would have mentioned it like this. Now, my dear NEET aspirants, what I can say in this particular case is that is kinetic energy of first. Okay, ratio is given as 4:1. So this is 4:1 will be equals to M2 divided by M1. So M1 by M2 will be 1 by 4. So M1 divided by M2 will come out to be 1 divided by 4. So the ratio of their masses, we are supposed to find the ratio of their masses. Okay. Object is of mass 4 kg. There is an object, its mass is 4 kg. Is moving with a velocity. Velocity in this particular case is given as I cap plus J cap. Find kinetic energy. We are supposed to find kinetic energy. Guys, we write kinetic energy is simply that is 1 by 2 mv square. 1 by 2 mv square. Now you tell me one thing. Am I supposed to take this velocity or I have to take the speed? I have to take the speed. That is magnitude of this velocity. That is under root of. How do you find the magnitude of velocity? What is the coefficient of this? 1. So 1 square plus. What is the coefficient of this? That is 1 square. So mod of V will come out to be 1 plus 1. It is root 2. Now, if I say kinetic energy, you will be simply saying kinetic energy is 1 divided by 2. Mass is given as 4 and velocity is given as root 2. So it is root 2 whole square. Square and root will cancel. So this 2 and 2 will cancel. So kinetic energy in this particular case will come out to be 4 joules. Kinetic energy will come out to be 4 joules. I hope this is crystal clear to each and every single student out there. Okay. Now guys, percentage change. Percentage change. Listen to me very carefully. Listen to me very carefully. What does percentage change actually mean? What does percentage change actually mean? See, let's suppose we have a quantity y is equal to x. Y is a physical quantity which depends upon x. Okay, we have a physical quantity y over here, it depends upon x. If I say if x changes, y changes. So how do I write change in x? Change in x is going to be delta x divided by x. Change in x divided by original value of x. Y is a physical quantity which depends upon x. If the value of x changes, y will change. So how do I write change in x? Delta x by x. It will be equals to delta y divided by y. Change in y. Now, if you have to find this change in percent, how many percent it has changed? 2%, 3%. You will be simply multiplying the percent over here. You will be multiplying 100 from this side. Multiplying percent means multiplying 100. This is what we call the percentage change. But this formula you can apply when change is small. When change is small. I'll make you understand. When change is small. So if let's suppose I would say up to 5%. Let's suppose if I'm saying x is changed by 5%, what will be change in y? Let's suppose if I am saying x is changed by 5%, what will be change in y? You'll be saying over here 5%, this will be also 5%. Now, guys, see, if let's suppose you have a quantity y is equal to x raised power n. You have a physical quantity y is equal to x raised power n. Okay. You have a physical quantity y is equal to x raised power n. We say y is a physical quantity which depends upon x. If x changes, y changes. How do we write change in x? Take this power down. You say delta x divided by x. Power down delta x by x. It will be equals to delta y divided by y. So when you have power, take it down. And if you want to multiply, and if you have to find this in percent, so this multiply with 100 from this side. So this will be percentage change in x or percentage change in y. Absolutely, sir. Absolutely, sir. We understood each and every single thing. Like we have y is equal to x square. So you can say in this particular case, power down, 2 down, delta x divided by x is equal to delta y divided by y. This is how we are supposed to write it. But this formula you need to apply when the percentage change is up to 5%. Next. Listen carefully, listen carefully, listen carefully, listen carefully. My dear NEET aspirants, I can say, listen over here. I can say, if the change is, let's suppose, large, if the change is, let's suppose, large, if the change is, let's suppose, large, listen carefully. Let's first understand this in kinetic energy. Let's suppose in case of kinetic energy, we say this is the formula of kinetic energy. Kinetic energy is P square by 2m. How can you write the change over here? I'll write it over here. Guys, see. So here, this is power down delta P divided by P. This is called change in momentum. And you have mass also. Take this mass in the numerator. It will become m raised power minus 1. So that minus 1 down, because if you take this in the numerator, it will become m raised power minus 1. Take that minus 1 down. So it will be delta m divided by m. So what are we supposed to do with this constant? Leave constant. It will be equals to delta kinetic energy divided by kinetic energy. Now, if you want to find this in percent, multiply with 100 and multiply with percent over here. I hope this is crystalline clear. I hope this is crystalline clear. What is happening? Oh, see. If let's suppose I am saying y is equal to x raised power n, okay, or if I say y is equal to x raised power n divided by this is m. Now in this particular case, what you are supposed to do is y is equal to this n down delta x divided by x, and take this m in the numerator, so it will be minus delta m divided by m. You can write it like this. Similarly, that's what I'm trying to say in this particular case. So first, this is the formula of kinetic energy. If momentum changes, kinetic energy changes. So how do we write change in momentum? Power down delta P by P. How do we write change in mass? Leave this 2 because this is constant. So how do we write change in momentum? So change in mass, delta m divided by m. If it is in the numerator, it will be minus over here. If it was in the denominator, it will be plus over here. And if you have to find this in percent, you multiply with 100 and you multiply with percent over here. Okay. This you need to apply. I'll show the questions also. This you need to apply when change is small. Then, my dear NEET aspirants, if the change is large, 300%, 400%, in that particular case, guys, see, if the change is large, then percentage change in kinetic energy will be final kinetic energy minus initial kinetic energy divided by initial kinetic energy into 100. Okay, take a look at the question. If the momentum is increased by 3%, then the kinetic energy will be, momentum of the body is increased by 3%. You are supposed to tell me what is going to happen with the kinetic energy in this particular case. Guys, see, they have not mentioned anything about the mass. So leave mass. So we say kinetic energy is equal to P square divided by 2m. Since they have not mentioned anything about the mass, whether it is changing or how many percent, so you can simply say kinetic energy is directly proportional to momentum square. Now, how can you make the equation over here? Sir, 2 delta P divided by P will be equals to delta K divided by kinetic energy. If you want to find this in percent, multiply with 100 and here multiply with percentage. This became the formula. Now it says momentum is increased by 3%. So in momentum, percentage increase in momentum. So what is given? Given in the question is delta P divided by P into 100. Okay. Delta P by P into 100. Its value is given as 3%. This is what we call percentage change in momentum. Percentage change in momentum is 3%. So how can I write percentage change in kinetic energy? So percentage change in kinetic energy, it is going to be 2 into, what is the value of delta P by P into 100? That is 3%. So I'll be writing over here 3%. So 2 into 3 is, I would say this will be 6%. So change in kinetic energy will be 6%. So that's what I was saying. If you are changing the momentum by some percent, how many percent kinetic energy is going to change? 6%. Now, if I say, sir, momentum is changed by 12%, tell me how many times kinetic energy is going to change? Sir, that is 2 into 12. Okay. I hope this is crystalline clear. I hope this is crystalline clear. Take a look. If the momentum, guys, give me the signal in the chat. So is this clear? Oh? Tell me in the chat. Quick, 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 quick. And smash the like button if you have not liked the session. Now see, if the momentum of a body increases by 200%, then kinetic energy will increase by, just a second. If the momentum of the body increases by 200%, here change is large. Here change is large. So if the change is large, in that particular case, we'll be saying final kinetic energy minus initial kinetic energy upon initial kinetic energy into 100. You'll be using this formula. So we say in this particular case, percentage change in kinetic energy, it is simply going to be, that is final kinetic energy minus initial kinetic energy divided by initial kinetic energy, and you multiply this with 100. Now, boys and girls, tell me one thing. We say since kinetic energy is proportional to momentum square. Kinetic energy is proportional to momentum square. So instead of kinetic energy, can I write momentum square over here? Yes, sir. So I can write this formula, percentage change in kinetic energy divided by Ke. It is going to be, instead of final kinetic energy, I can write final momentum square minus, I can write initial momentum square. Yes, upon, I can write initial momentum square and then multiply with, I would say 100 over here. Then multiply with 100 over here. Now, guys, if the momentum of a body is increased by 200%, listen to me very carefully. I'm saying over here, listen, sir, what is initial momentum? Initial momentum, let's suppose it is P. Okay, it is P. Okay. P means how much P? 100% of P. Sir, what is final momentum? Final momentum is, it is increased by 200%. Already it was 100%. So total is how much? 300%. 300% of P. Sir, momentum of a body is increased by 600%. Momentum of a body is increased by 25%. Already it was how much? 100. Now you are increasing by 25%. 100 plus 25 is 125. So I can say, sir, this final momentum in this case will be, listen carefully, sir, this is 300%. 300% you can write 300 divided by 100 into P. 40% means 40 by 100. 30% means 30 by 100. So this and this will cancel. So final momentum is going to be 3P. Initial is P. So now put it over here. So this will come out to be, final momentum is, I would say 3P whole square minus initial momentum is P square upon initial momentum is P square into, I would say 100. Okay. So this is 3P whole square, that is 9P square minus P square is 8P square. Okay. 8P square and divided by, I would say in this particular case, this P square into, I would say 100. P square and P square will cancel. So 8 into 100, it is going to be 800%. So this will be increased by 800%. Please tell me in the chats if this is crystalline clear. Please tell me in the chats if this is crystalline clear. So percentage change in, if momentum is increased by 2%, 200%. So kinetic energy will be changed by how many percent? I would say 800%. 800%. I hope this is crystalline clear. Now, if I say in the same question, boys and girls, see. If I say momentum is increased by, let's suppose momentum is increased by, listen carefully, 50%. So what is going to be the final momentum in that case? I would say 150% of initial momentum. Let's suppose initial momentum is P, final momentum will be 150%. Because already it was 100. Now you are increasing by 50%. So how much it will be? 150%. So how can I write this? This will be 150 divided by 100 of P. This and this will cancel. 5 2s are 5 3s are 15. So this will be 3P divided by 2. Now if I say percentage change in kinetic energy, you'll be saying, sir, percentage change in kinetic energy, delta Ke divided by Ke. It is going to be final momentum square minus initial momentum square divided by initial momentum square, okay, into I would say 100. Now put the value of final momentum, 3P by 2 whole square, initial momentum P square into 100 and get the answer. I hope this is crystal clear to each and every single student. Now you have, my dear NEET aspirants, in this particular case, that is work energy theorem. Work energy theorem. Okay. Now, what does work energy theorem actually mean? See, work energy theorem simply means work done by all the forces is equal to change in kinetic energy. Work done by all the forces is equal to change in kinetic energy. All the force means conservative force, work done by conservative force. Work done by non-conservative force. Conservative force is that force which does not depend upon the path, like gravity. Okay. Non-conservative force means friction, which depends upon the path. Friction along different paths, work done by friction along different paths will be different. So, work done of friction depends upon path. So, that's a non-conservative force. Work done of conservative force does not depend upon the path. Example is gravity, example is friction. Internal force, work done by external force, this is equal to change in kinetic energy. Change in kinetic energy means final kinetic energy minus initial kinetic energy. Work done is equal to change in kinetic energy, final minus initial. Okay. Let me just give you the example over here. This will give you the crystal clear feel. Let's suppose velocity of this body is V is equal to a root of 120. See guys, in this particular case, this is the crystal clear. This is a crystal clear. This is a crystal clear example which will give you the proper feel of work energy theorem. Listen carefully. See guys. We have a block over here, its mass is 10 kg. Okay. And coefficient of friction in this case is acting over here 0.4. Coefficient of friction is 0.4. Okay. External force is acting as 100 Newton. Displacement done by the body is 10 meters. And mass of the block is 10 kg. And the velocity achieved by the body over here is root 120. Here it is at rest. First of all, let's find work done by all forces. I'll write over here. Let's find work done by all forces. Okay. First and the foremost thing, I'm going to calculate what is the work done by external force. That is F, S, and then we say cos of 0. Because force and displacement are in the same direction. So value of F is 100 and value of S is 10. Cos 0 is 1. So this will be 1000 joules. So work done by external force is 1000 joules. Okay. Let's find, my dear friends, work done by friction. That is frictional force, displacement S, and then we say cos of 180. Because frictional force is backward, this is forward. Okay. So this work done by frictional force is, how do we write the friction? Friction is mu m into g. This is the value of frictional force, mu m into g. And then we say S and cos 180 is minus 1. What is the value of mu? Mu is given as 0.4, that is 4 divided by 10. What is the mass of this object? That is 10. What is acceleration due to gravity? That is 10. G is 10. What is displacement? That is also 10. And then we say minus 1. So this 10 and 10 will cancel. 4 into 10 is 40, into 10 is, this is 400. Okay. This is minus 400 joules because this is minus 1. Okay. Let's find, my dear friends, we say work done by the gravity. So gravitational force is acting also on this one. So I would say work done by mg. That is going to be force mg. Displacement is S, and then we say cos of 90 because angle between gravity and displacement is 90. So work done in this particular case is 0. Okay. This work done by gravity. Now these are the forces which are acting over here. So friction is non-conservative. This is work done by non-conservative. Okay. Gravity is conservative. This is work done by conservative. This is external. Now, if I say work done by all forces, work done by all forces, how much will you say? So that is 1000 by external minus by friction, it is 400. So this will come out to be 600 joules. Yes. Now, guys, let's find change in kinetic energy. Let's find change in kinetic energy. So how do we write change in kinetic energy? So change in kinetic energy means final kinetic energy minus initial kinetic energy. So change in kinetic energy is simply going to be final kinetic energy 1 by 2 m v final square minus 1 by 2 m v initial square. Okay. Yes. Now, guys, what I can write in this particular case, 1 by 2 m v final minus v initial. What is the final velocity of the object? Final velocity of the object is root 120. So that is a root 120 whole square. Minus initial velocity is 0. So this will be 1 divided by 2. What is the mass of the object? That is 10. And root 120, this and this will cancel. So this will be 120. Square and root will cancel. 2 ones are 2 60s are. 60 into 10, that is 600. So change in kinetic energy came out to be 600. Work done by all the forces is 600. So can I not say work done by all forces in this particular example is equal to what? Change in kinetic energy. And this is what I can say. This is what we call work energy. Work done by all the forces is equal to change in kinetic energy. Work done by all the forces is equal to change in kinetic energy. Even if I asked you, what is the velocity of the object over here? You'll get the velocity of the object over here, root 120, by putting this equal to change in kinetic energy is equal to 600. Then if you solve, this will come out to be root 120. Is this clear? Please tell me in the chats, everybody out there. This previous slide. Oh. Let's take a look at this question. A particle of mass 3 kg, okay, is moving along x-axis and its position at time t is given by, this is the position of the particle, x is equal to 2t square plus I would say 5. Work done by all the forces acting on it in time t is equal to 0 to t is equal to 3 will be. We have to find the work done. Work done from t is equal to 0 to t is equal to 3 seconds. We have to find the work done from t is equal to 0 to t is equal to 3 seconds in this particular case. Okay. Now, my dear NEET aspirants, this is the this is the position. Let's find velocity. Velocity is simply differentiation of this position, dx divided by dt. Now tell me, what is the differentiation of this? 2 into 2 is 4t. Differentiation of this is 0. Now tell me, at t is equal to 0, what is the velocity, initial velocity? Sir, put t is equal to 0 over here, velocity will be 0. 4 and 0 is 0. At t is equal to 3 seconds, what is going to be the final velocity? Because we have to find the work done from t is equal to 0 to 3. Final velocity will be 4 into 3, that is going to be 12 meter per second. Now we have to find the work done. We can use work energy theorem. We say now, can I say work done by all the forces is equal to change in kinetic energy? So I can say work done by all the forces is change in kinetic energy is 1 by 2 mass into V final square minus V initial square. So in this particular case, work done will be 1 by 2m. What is the mass of the object? That is 3. Final velocity, it is 12 square. 12 square minus initial velocity is 0. Okay. So W is equal to 3 divided by 2 into 12 square is 144. Okay. Okay. 2 ones are 2, 7s are 2, 2s are 4. 3 into 72. Is this clear? Is this clear? Tell me, guys. Is this clear? Okay. Two 216 joules. Tell me, guys. Is this clear? Now, guys, let's move on to this one. A particle of 2 kg travels along a straight line with velocity v is equal to a root x. There is a particle. It has velocity v is equal to a under root of x, where a is a constant. The work done by the net force during the displacement of x is equal to t to x, 0 to x is equal to 4. We have to find the work done. From x is equal to 0 to x is equal to 4. Again, we will use the work energy theorem. Guys, tell me what is the initial velocity. We say at x is equal to 0. Let's find initial velocity. So velocity is given a root x. Put the value of x is equal to 0 over here. Initial velocity will be 0. And then if you put the value of x is equal to 4, what is the value of velocity, final velocity? Put instead of x over here 4. So a under root of 4. So this is going to be 2a, because root 4 is 2. Now apply work energy theorem. That is going to be work done by all the forces equal change in kinetic energy. So I can write 1 by 2, and then we say mass into final velocity minus initial velocity. It's square. Okay. Just a second, I'm seeing this board. It's a little bit, v is equal to a root x. Okay. Now guys, this work done is going to be 1 by 2 mass. Mass of the object in this particular case is 1 divided by 2. Mass is 2. Final velocity square. What is final velocity? That is 2a whole square. Minus initial is 0. This 2 and 2 will cancel. So this is going to be 4a square. So this is the work done. Is that clear? Now take a look at this particular question. See guys. Velocity time graph of the particle is of mass 2 kg is shown. This is the velocity time graph. Guys, what is the value of time over here? That is 0. What is the value of time over here? That is 2 seconds. We say at t is equal to 0. What is the velocity? That is 20. Initial velocity is 20. And what is the value of velocity at t is equal to 2 seconds? We say velocity is 0 because graph is coming down. So at t is equal to 2 seconds, velocity is 0. You have to find in this particular case, find the work done by all the forces. Work done by all the forces is change in kinetic energy. That is 1 by 2 m into final velocity square minus initial velocity square. So work done by all the forces 1 by 2 m. What is the value of mass? That is 2. Final velocity square. Final velocity is 0 square. Minus initial velocity square. That is 20 square. This and this will cancel. So work done in this case will be 20 square is 400. So minus 400 joules. Minus 400 joules. Okay. Okay. A bob of mass m attached to a string of length L. See guys, this is another question. You have a bob, it is attached to a string L, its length is L. Okay. It is released from angle theta. So already bob is over here at an angle theta. You are releasing the bob. When you release the bob, find the velocity when it crosses the mean position. It will come. What is the velocity when it crosses the mean position? What is the velocity when it crosses the mean position? See guys, directly you will be remembering over here. So already bob was here. When you release the bob, with what velocity you can cross? It will cross the mean position. V is equal to under root of 2g. G is acceleration due to gravity. L. L is the length of the string. And then I can say in this particular case, it is 1 minus cos of theta. 1 minus cos of theta. Directly remember, if you have a bob, if you are releasing this bob, what is the velocity with which it is going to cross the mean position? In that particular case, you simply are going to say, that will be what? 2g under root of 2gl 1 minus cos of theta. Now see, let's suppose you have released the object from here at 90 degree. What is the value of theta? 90. What is the velocity when it crosses the mean position? See guys, in this particular case, v is going to be under root of 2gl 1 minus cos of theta. So I can write 1 minus cos of 90. Cos 90 is 0. 1 minus 0 is 1. So v will be under root of 2g into l. So L in this particular case is length of the string. Length of the string. Okay. Like you have, if the bob is here only, this is length L. Now, could you please tell me what is the value of theta? Guys, theta in this particular case is 0 because it has not moved. If I say if you take it over here, angle will be 90. In this case, angle is 0. So what is the velocity? Under root of 2gl, then 1 minus cos of 0. Because theta is 0. Cos 0 is 1. 1 minus 1 is 0. So velocity is going to be under root of 2gl into, I would say, 0. This entire term would be 0. So velocity in this particular case is 0. Velocity in this particular case is 0. So means if you have an object over here, so it is at rest. If you release it, it will still remain at rest. That's why we got 0 velocity. 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 Is this clear? Tell me in the chat. Okay. Now, boys and girls, let's move on to the concept of potential energy. Let's move on to the concept of potential energy. Let's move on to the concept of potential energy. I want you guys to understand, it will hardly take us one more hour, okay? So till 10, we'll be finishing the chapter. So I want you guys to give me 100% of your attention. See guys, how do I define the potential energy? Let's suppose you have, this is the surface over here. And on this surface, you have placed an object. You have placed an object on the surface. This is the object which is placed on the surface. This is the object which is placed on the surface. Now, my dear NEET aspirants, if I am saying you are taking this object to the certain height, I would say this is the height. You are taking this to the height, I would say h. Okay. Who is taking this object to the height h? Sir, it is me. Who am I? I am the external agent. I am the external agent. So can I say, if I have to take the object to the height h, I have to do the work done? Yes. So I would say, on lifting the object to the height h, on lifting the object to the height h, work has to be done. Work has to be done by the external agent. By the external agent. By the external agent. So if you are lifting this object from here to here, you have to do the external work done. Now, that external work done by the external agent will be stored in the form of potential energy. That work done will be stored in the form of potential energy of this object. It is like, my dear friends, I am lifting the object, I am using my own energy. Sir, where will that energy go? Sir, that energy will be stored in the form of potential energy of this object. Okay. Now, let's suppose on the surface, it has got some potential energy already, Ui. When you lift the object, we know its potential energy will increase. So we say here potential energy will be UF. So can I say when you lifted the object, then only potential energy changed? Absolutely, sir. So I can say in this particular case, due to the external work done, I would say potential energy of the object is changed. I would say potential energy of the object is changed. So that's what I'm mentioning over here. This external work done is equal to change in potential energy. This external work done is equal to change in potential energy. So what I can say, so due to the external work done, I would say potential energy of the object is changed. Absolutely, sir. If I say, sir, it has some potential energy already stored over here. Let's suppose 10 joules. Now you lifted the object and you took it to this particular point. Now potential energy is 20 joules. So we say change in potential energy is 20 minus 10, that is 10. Okay, absolutely, sir. Now, if I say in this particular case, how much work you did in lifting the object, sir, work done by this external agent. Listen to me very carefully. Listen to me very carefully. You said, sir, this external force, this is the external force. Okay, this is the external force. And in the downward direction, this is mg. You can say, sir, this external force. And then you say in this particular case, this is mg. And then you can say cos of 0. So this is work done by the external force. Listen to me very carefully. In this particular case, we say whatever is the value of mg, we apply exactly the same as external force. The external force is exactly same as the value of mg. So I can write over, wait, I made a mistake. External force into displacement is h. So instead of external force, I can write over here mg and then we say h. This is the work done by the external agent. This is the work done by the external agent in this particular case. Okay. So my dear NEET aspirants, we say as here we say whatever is the value of external force, because we are taking this object slowly till here. Same is the value of mg. Oh, how do we find the work done by external agent? That is external force multiplied by h into cos of 0. Now, if I am saying whatever is the value of mg, same I am keeping the external force, because I have to bring the charge, I have to take this mass slowly. So then instead of external force, I can write this external work done will be, that is mg, and this is h, and cos of 0 is 1. This is going to be the work done by external agent. Tell me guys, is this clear? Tell me guys, is this clear? Is this clear? Okay. So my dear NEET aspirants, what is potential energy? When you lift an object from here to here, you do the work done. That work done is stored in the form of potential energy. So due to that work done, potential energy is changed. By the way, you represent potential energy with U. And how much is that work done? That is mg into h. Now, one more important thing I just want to mention over here. What is that? What is that? See guys, if I say, what is the work done by mg? This is work done by external agent. Okay. Now, what is the work done by mg? Sir, that is mg, force into displacement is h. Force is downward, displacement is upward, h. And then we say cos of 180. Absolutely, sir. So work done by this mg is equal to minus mg into h. mg means conservative force. So we can say this is work done by conservative force. We can write it like this. Work done by conservative force. Work done, I'll be sharing the notes in the Telegram. Work done by conservative force. I can write it like this. Now, my dear NEET aspirants, if you can clearly see over here, sir, this work done by conservative force is equal to this negative mgh. What is mgh? That is work done by external agent. Yes, sir. So can you say, sir, work done by conservative force is equal to negative of work done by external agent? What is work done by external agent? That is delta U. I hope you got the crystal clear feel of this. So work done by external agent, external force is equal to change in potential, positive of change in potential energy. Work done by conservative force is negative of change in potential energy. I say work done by mg is equal to minus mgh. That is work done by conservative force. Instead of mgh, I can write work done by external agent. Okay, so work done by conservative force, instead of work done by external agent, I can write delta U. So from now onwards, there are only two things you'll be remembering over here. First is, guys, see, work done by conservative force is equal to positive of change in potential energy. Very important equation. This we will be using in the electrostatics, in gravitation, in magnetism, in modern physics, everywhere. And work done by external agent is equal to work. I made a mistake. Wait. Work done by conservative force is equal to negative of change in potential energy. Work done by external agent is equal to positive of change in potential energy. Tell me, is this clear? And you can write it like this also. You can write it like this also. Work done by conservative force is equal to negative of change in potential energy means final potential energy means minus initial potential energy. Something like this. Okay. Something like this. Now, guys, one more important thing I just want to mention over here. What is that? Let's suppose if you are displacing this ball by a large displacement, means you have done the large work done. Due to large work done, there will be large change in potential energy. Now, if you displace a ball by a small amount, I can say due to small work done. Due to small work done, there is small change in, due to small work done, there is small change in potential energy. Due to small work done, there is small change in potential energy. Okay. So how can we write small work done? That is dW is equal to small change in potential energy is minus du. And if I say this is due to the conservative force, now you can take this negative over here. Du can be written as, you can write this du as, that is minus dW. Okay. Now you can write this du as minus dW. How do we write the small work done? Small work done means force multiplied by small displacement. Yes or no? Yes. Now to find total work done. To find total work done, what I can write in this particular case, we do integration. Integration of du is equal to minus integration of f ds. Now, what is integration of du? Du means small change in potential energy. If you do the integration, it will be large change in potential energy, delta u, minus integration of f, and then we say ds. What does this equation tell you? This equation tells you, if you have force, you want to find potential energy, you will do what? Integration. One more equation I can make over here, that is, I can say this force will be simply, that is minus du divided by ds. So if you know the potential energy, you want to find force, you will have to do the differentiation. From this equation we got this, from this equation we got this. Okay. So if you know potential energy, you can find force by doing the differentiation. If you know force, you can find change in potential energy by doing the integration. I hope this is crystal clear to each and every single student. Okay. Now, one more important thing. Take a look at this question. Slope of U versus R graph. See, guys, if I make the graph between potential energy versus R, or let's suppose S, potential energy versus S graph. Okay. Now, guys, let's suppose the graph is something like this and this angle is theta. If somebody asks you what is the value of slope in this particular case, so you'll be simply writing the slope in this particular case is tan theta. Slope of any graph means tan theta. Tan theta is perpendicular by base. So whatever is on this axis, this is base, and that is this. This is du divided by ds. If it is UR graph, let's keep it UR only. It's one and the same thing. Du by dr. Now, my dear friends, we recently studied, as we know that this force is equal to minus du divided by dr. This we recently studied. This is the relation between force and potential energy. If you know the potential energy, you can find force by doing the differentiation. Okay. So can I say this is equation first and this is equation second? So what will I say from equation first and equation second? Guys, du by dr is slope. Du by dr is negative of force. Take this negative sign over here. So can I say slope is simply what? Negative of force. So take this negative over here. Force is going to give you negative of slope. I would say negative of slope. So means if you have potential energy versus R graph and you have to find force, you'll be finding what? You'll be finding what? Slope, and put the negative sign in front. Area under FR graph. If you have force versus R graph, if you let's suppose have force versus R graph, okay? If you have let's suppose force versus R graph, this is force versus R graph. And if you want to find out area under this graph, if you want to find this area, what will you say area? Area in this particular case will be simply integration of whatever is on y-axis f and whatever is on x-axis dr. Okay. Now we recently studied, as we know, what do we know? That change in potential energy delta U is negative of integration of f dr. This we have recently studied. Delta U is equal to integration of FDR or FDS. So can I say I can call this as equation first and I can call this as equation second? So can I say from first and second? From equation first and second. Take the negative sign over here. So I can say this area is going to be negative of change in potential energy, because integration of FDR is negative of change in potential energy. Integration of FDR is area. So change in potential energy is going to be negative of area. I'll be showing you the questions also. You don't have to worry about anything. So the theory is completed. I hope this is clear. Now let's move on to this question first. Come on, tell me, is this clear? Now guys, let's take a look over here. If the work done by conservative force to move an object from A to B is 50 joules, listen to me very carefully. If the work done by conservative force to move an object from A to B, let's suppose this is point A and this is point B. If an object is moved from A to B, so work done by conservative force, it is 50 joules. It is 50 joules. Okay. If the work done in moving the object from A to B is 50 joules, then find the potential energy of A. Then find the potential energy of A. We have to find the potential energy of A. And if potential energy of B is minus 20 joules. Now tell me guys, listen carefully. We say, as we recently studied, work done by conservative force is equal to negative of change in potential energy. We say work done by conservative force is equal to minus, I would say, U final minus U initial. U final minus U initial. I would say work done by conservative force is equal to minus final potential energy. My dear NEET aspirants, the object moves from A to B. Object moves from A to B. So I can say final potential energy is going to be B minus initial potential energy is going to be A. Absolutely, sir. Absolutely, sir. Okay. Absolutely, sir. Now, in this particular case, work done by conservative force is given as 50 is equal to minus. Potential energy of B is given as minus 20 joules. So I'll write over here minus 20 minus, I would say, UA. So this is 50 is equal to, now in this particular case, minus into minuses, I would say plus. So this is going to be plus 20 joules. And then minus into minus is going to be plus. This will be plus UA. Now take it over there. So UA will come out to be 50 minus 20, that is 30 joules. So this is what we were supposed to find. Tell me guys, is this point clear? Is this point clear? Now guys, if work done by conservative force is 30 joules, if work done by conservative force is 30 joules in moving the object from A to B, now my dear NEET aspirants, if we move an object from A point to B point, if we move an object from A point to B point, okay, if work done by conservative force is minus 30 joules, okay, so I would say work done by conservative force is minus 30 joules. Okay, you are moving an object from A point to B point. If potential energy at point A is 30 joules, potential energy of point A is given as 30 joules. Okay, then find the potential energy of B. Now guys, we can use the formula work done by conservative force is equal to negative of change in potential energy. That is final potential energy minus initial potential energy. So you can say work done by conservative force is going to be minus final point. Object moves from A to B. So it is going to be UB minus, I would say, UA. So I would say work done by conservative force is equal to, this is minus UB. Final point is B. So potential, if the potential energy, okay, we have to find the potential energy of B minus, what is the potential energy of A? That is given as 30 joules. I can write over here. And what is the work done by conservative force? That is given as minus 30 joules. It is given right like this. Now this is minus 30 over here is equal to minus into minus is plus. Sorry, minus into plus is minus, minus into minus is plus, so plus 30 joules. Now, my dear NEET aspirants, take it over there. So I can say minus UB will be equals to minus 30, it will be minus 60. This and this will cancel. So potential energy of point B is, I would say, 60 joules. Please tell me in the chats if this is clear. Tell me, guys, is this clear? This is plus 60 joules. I hope this point is crystal and clear. Okay. So I have told you area under force versus R graph. Area under force versus R graph. That gives you change in potential energy. Now, guys, take a look over here. The variation of potential energy U of a system shown in the figure. This is U versus X graph given. The force acting on the system is best represented as, we have to plot the graph between force. We are supposed to plot the graph of force. See, guys, listen to me very, very carefully. It is U versus X graph. Listen, guys, U versus X graph or U versus R graph. Now, if you have to find the force from UR graph, what will you find? Slope, and you'll be putting the negative sign in front. Now, take a look. Let's suppose this is point A, this is point B, this is point C, and this is point D. See, guys. See, guys. If I say in this particular case, slope of AB. If I say in this particular case, slope of AB. This is the graph. This is the graph. This is theta. Always remember, my dear NEET aspirants, whenever is the value of theta less than 90, in that case, always remember slope is going to be positive. Okay. Now, if slope of AB graph is positive, okay, and slope is constant, why, sir? Because it's a straight line. Slope is positive and constant. Now tell me what is going to be the force. Sir, force is negative of slope. Force is negative of slope. So I can write over here force is going to be negative of slope. In this case is positive and constant. So whatever is the value of slope, that will be positive. Negative into positive is negative. So force in this case will be negative. I would say for AB, force in this case is negative and is constant. Why? Because slope is constant, so force is constant. So force will be negative and constant. Now let me plot the graph of AB. If I say I have to plot the graph between force and X. So for AB, I have to make the force constant and negative. Sir, force will be positive from the upper side, force will be negative from the lower side. So this is force, constant and negative. Now, my dear NEET aspirants, let's talk about this B and C. When we talk about slope of B to C, so this is parallel to x-axis. So in this particular case, I would say theta is 0. If theta is 0, I would say slope is 0. So if slope is 0, I would say force is 0. So means from B to C, the graph has to be on this axis. This axis. Because here force is 0. Then, my dear NEET aspirants, I would say from C to D, we say slope of C to D. So for this, I would say theta is greater than 90, my dear NEET aspirants. So theta is greater than 90 and less than 180. In that case, always remember value of slope is going to be negative. Guys, remember this from now onwards. Theta is less than 90, slope is positive. Theta is 0, slope is 0. Theta is greater than 90, less than 180, slope is negative. So if slope is negative and constant. Why, sir, constant? Because it's a straight line. For straight line, slope is always constant. So when we write force, When we write force, force is negative of slope, negative of slope. Okay, so force in this particular case will be negative of slope. In this case is also negative. It has value, but that would be negative, -5, -10. So in this case, force will be positive and constant. So if I make the graph afterwards, it has to be positive and constant. So positive force will be from the upper side. Positive force will be from the upper side and constant. So this force is positive and constant. It was a good question actually. Okay. Now take a look at this particular question, guys. See. One thing I just want to mention over here. What is that? Let's suppose if, see guys, the question, if potential energy of an object is U is equal to, if potential energy of an object is U is equal to 4x square plus 2x plus 1, then find force. Find force at x is equal to 2 meters. Understand this very carefully. In this particular case, force potential energy is given in terms of x. Now tell me, my dear NEET aspirants, recently I have told you, if you see, recently I have told you, wait, if potential energy is given, you are supposed to find force. You will have to do the differentiation. So you will simply say, sir, force in this particular case is minus du divided by dr or du by dx. So you will have to do the differentiation in terms of xy because potential energy is given in terms of x. So you will be saying, sir, potential F is equal to minus du by dx, differentiation of this. Now tell me, what is differentiation of 4x square? That is 8x. What is differentiation of 2x? That is 2. What is differentiation of 1? That is 0. Now we have to find at x is equal to 2. We say at x is equal to 2 meters. So force will come out to be minus, and this will be 8 into, here it is 2 plus I would say 2. So 8 into 2 is 16. 16 plus 2 is 18. So force is going to be, I would say, minus 18 Newton. So this came out to be the force. So what I wanted to say in this particular question is that if potential energy is given in terms of x, you are supposed to find force, you will have to do the differentiation in terms of x only. Now, what if, my dear friends, potential energy is given in terms of x, y, and z, like this question. If potential energy is given in terms of x, y, and z, then you are supposed to find force. What will you do in this particular question? That is a task. See, guys, in this particular question, here we do partial differentiation. Here we do partial differentiation. Okay. See, guys, here we have to do the partial differentiation. Partial differentiation means differentiation with respect to x. See. I'll tell you. We'll say, sir, we'll find x component of the force by doing the partial differentiation. That is, this is what we call partial differentiation. Dou u divided by dou x. Please wait for me. I'll write this equation, then I'll show you the question that will make you understand. So dou u by dou x, in this particular case, y and z will be considered as constants. And then you will find the y component of the force, that will be dou u divided by dou y. In this particular case, x and z will be considered as constants. And then we say z component of the force, that is minus dou u divided by dou z. In this particular case, x comma y will be considered as constants. Now, my dear NEET aspirants, if you say force is going to be, that is fx into I cap. Okay. And then plus fy into j cap plus fz into, I would say, k cap. Then you can say this force will be instead of fx, guys, this is a force, this is x component, y component, z component. Then instead of this x component, I can write, take this minus out, that is dou u divided by dou x. Dou means partial differentiation. Okay, dou u by dou x into I cap plus dou u by dou y into j cap. Then plus dou u by dou z into, I would say, k cap. Okay, this one. Okay. So this is what we are going to do. Now let's try to look at the question first. Then only you would be able to understand what I'm trying to say. See, guys, here potential energy in this particular case is given. Take a look. Potential energy in this particular case is given as xy plus yz plus zx. Now, when potential energy is given in terms of x, in terms of y, in terms of z, in that particular case, you have to do the partial differentiation with respect to x, with respect to y, with respect to z. But if it is given in terms of x only, then you will have to do the differentiation in terms of x only. If it is given in terms of y only, then you will have to do the differentiation in terms of y only. Now, guys, first, let's do the partial differentiation with respect to x. We have to find force. See the approach that I'll use. Let's do the partial differentiation with respect to x. When you do partial differentiation with respect to x, means you are doing differentiation with respect to x only. Y and z will be considered as constants. That is what is the meaning of partial differentiation. So then we can say, sir, this fx will be minus dou u by dou x. Take a look, guys. Differentiation of this with respect to x. Y and z are constants. Now, what is the differentiation of xy? Y is constant. Sir, that will be y. From this term, we'll get y. Okay. And this minus is out. So it is y. What is the differentiation of yz, my dear NEET aspirants? What is the differentiation of this term yz, my dear NEET aspirants? Sir, y is constant, z is constant. Differentiation of constant is 0. What is the differentiation of zx, my dear friends? It is going to be, sir, z, because x is constant. Then, my dear NEET aspirants, if I say fy, y component, then, my dear NEET aspirant, this is minus. We say dou u, second I'll write, then differentiate with respect to, differentiate partially with respect to y. And in this particular case, x comma z will be considered as constants. So you'll be getting fy is equal to minus dou u divided by dou y. Minus dou u divided by dou y. Okay. Now, my dear NEET aspirants, what I can say in this particular case, this will be minus differentiation of this with respect to y. Okay, x and z will be constant. So x is constant. What is differentiation of this xy? It is going to be x. Why, sir? Because y is constant. Now, differentiation of this is going to be, sir, z, because we are differentiating with respect to y. So z is constant. Zx is constant, differentiation of this term will be 0. This is what we call the y component. Then I would say differentiate partially with respect to z. In this particular case, x comma y will be considered as constant. X comma y will be considered as constants. So you will be saying, sir, fz is going to be minus dou u divided by dou z. Then we say minus. Then, my dear NEET aspirants, differentiation of this with respect to z. X and y will be constants. So this differentiation of this is 0. Then differentiation of this will be y. Then plus differentiation of this will be over here x. So you got fx, you got fy, you got fz. Now, how can you write this? Guys, see. Now, this f will be, listen carefully. Sir, it is fxi cap plus fyj cap plus fzk cap. Yes, sir. Now, you will be writing, sir, f is equal to fx. What is the value of fx? Sir, take this negative out because negative is common in all. Then, fx. What is the value of fx? Sir, minus dou u by dou x. So that is going to be minus y plus z. So it is y plus z. And I'll be mentioning over here I cap plus. What is the value of fy or minus dou y by dou y? So that is going to be, I would say x plus I would say z and I would say j cap. Then I would say this fz, instead of fz, I can write over here y plus x and I would say over here k cap. This came out to be the force. Now, boys and girls, it says at 1, 1, 1. We say at 1, 1, 1. Means value of x is 1, value of y is 1, value of z is 1. So what can you write over here? This force is going to be minus. See guys, put 1 here, put 1 here. 1 plus 1 is 2. So this will be 2i cap. Put 1 here, put 1 here. 1 plus 1 is 2. So this will be 2j cap. Put 1 here, put 1 here. 1 plus 1 is 2 and this is k cap. Tell me, boys and girls, this is the force that you got. Even you can find the magnitude of force also. This is a good level question. So you can say under root of 2 square plus 2 square plus 2 square. That is 4 plus 4 plus 4. So this came out to be under root of 12 Newton. Please tell me in the chats if this is crystalline clear. Everyone means everyone. Everyone means everyone. The potential energy of a particle is given by as ax minus bx square. Now see guys, here you don't have to do the partial differentiation. Here potential energy is in terms of x only. And it says find the equilibrium position of the particle. Equilibrium position is, see guys, we say to find the position where net force is equal to 0. To find the position where net force is equal to 0. Now guys, see, this is the potential energy. You have to find the net force, then put it equal to 0, and then get the value of x. That is what we call the equilibrium position. Now guys, we can say here force will be simply that is minus du divided by dx. Force will be minus du divided by dx. And in this particular case, I can say, sir, are we supposed to differentiate with respect to x only? Yes. Why? Because potential energy is given in terms of x only. So it is going to be minus differentiation. This is minus. Tell me, what is the differentiation of ax? It is going to be a. So this is going to be minus. This is going to be a. And then minus 2bx. Okay. Then my dear NEET aspirants, F is equal to minus, so this is basically the force. So minus, this will be minus A, and then we say plus 2bx. So put this force is equal to 0 because we have to find that position where net force is 0. So put this force is equal to 0, take it over there. So 2bx will be equals to A. So x will be equals to A divided by 2b. So this is the position where net force is equal to 0. Even if you put it over here, you'll get the net force is equal to 0. So put it over here, A divided by 2b. See guys, check, you can check it also. F is equal to minus A plus 2b. And instead of x, you can write A divided by 2b. This 2b and 2b will cancel, plus A minus A will be cancelled. So I would say it is 0. So that's what I was saying. You have to find that position where net force is 0. That is what we call the equilibrium position. Okay. 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 So this is done. This is done. This is done. This is done. Now guys, take a look. Potential energy with respect to the reference line. Potential energy with respect to the reference line. Oh, we have to complete the chapter. What are you guys doing? Do you want me to skip the topics? Study, huh? Smash the like button if you are not like the session yet. Come on, do it quick. Mark your attendance. Take a look. Potential energy with respect to the reference line. Understand this very carefully, my dear NEET aspirants. Let's suppose this is the surface. This is the surface of Earth. And you are considering this as a reference line. Always we take the reference line. We find potential energy with respect to a reference line. We say potential energy on the reference line, we always consider 0. Keep that thing in your mind. Now, above the reference line, at height h, I would say potential energy is going to be m, g, and h. And then, my dear NEET aspirants, below the reference line, at depth h, you'll be considering potential energy minus mgh. Keep this thing in your mind. If I say object is here, which is having the mass h, which is having the mass m, its potential energy will be mgh. Okay. Sir, how mgh? How mgh? I have told you work done will be stored as potential energy. Work done will be stored as potential energy. So how much is this work done? So due to work done, potential energy will be changed. So if you take the object from surface to height h, so it is going to be final potential energy minus initial potential energy. So initial potential energy is 0 because on the reference you are considering it 0. So this is 0. So this work done or this work done, I would say final potential energy is equal to, I would say, work done. So now work done will be how much? So it is mg is force, h is displacement, and then we say cos of theta. And in this particular case, I can say this is cos of 0. Now, my dear friends, in this particular case, it is going to be, that is mg into h. So that's what I'm saying. So you'll be taking this as mgh. Simply on the reference line, consider it 0. Above the reference line, consider it positive. Below the reference line, consider it negative. Plus mgh and minus mgh. Like, let's take a look at this particular question. See, guys, find the potential energy of the rod as shown in the figure. See, guys, we say if this is the rod, we consider its mass at center of mass at this point. Consider the mass of the rod at center. So potential energy of the reference line is 0. Potential energy of this is going to be, that is mg. Mass, g is the acceleration due to gravity, and at height, at what height mass is present? L divided by 2. So here I can say potential energy is going to be minus mg and L divided by 2. Minus mg and L divided by 2. Okay. Like this one. If let's suppose this chain is hanging over here, you are considering this as reference. So potential energy on the reference line you will be considering as 0. So this portion has 0 potential energy. Now guys, tell me one thing. This is the length L by 2. So what is the potential energy of this? Understand this very carefully. Guys, mass is m, length is L. How much is this length? L by 2. So this center of mass will be over here. You are considering the mass of the chain, this portion over here. So this is at what distance? L divided by 4. Because this is L by 2 total. So half of L by 2 is how much? L by 4. So now, and mass you will be considering how much? M divided by 2. Why? Because entire chain has mass m by 2. Sorry, m. So half will have mass m by 2. That's what I'm saying. And center of mass will be present at L by 4. So now potential energy will be m minus, instead of m, it is going to be m by 2. And then we say g, then we say L by 4. So potential energy will be minus m g L divided by 8. Please tell me in the chats if this is clear. Please tell me in the chats if this is clear. Please tell me in the chats if this is clear. Okay. Now we have the next concept, that is what we call the spring potential energy. Now we have the next concept, that is what we call the spring potential energy. Take a look, my dear NEET aspirants. How much is the spring potential energy? Listen to me very, very, very carefully. See, guys, let's suppose you have a spring over here. Okay. And there is a block attached to the spring. Now, my dear NEET aspirants, let's suppose here block is at mean position. So x initial is 0. And you are displacing this block by doing the external work done to x final. It is equal to x. Listen carefully, please. So we say you are applying the external force in this particular case, and the spring is creating the restoring force. Can I say in this particular case, when you elongate the spring, in that particular case, you have to do the work done. So we say on elongating the spring, I would say work has to be done. Okay. So that will be stored in the form of potential energy of the spring. That will be stored in the form of potential energy of the spring. So means whatever the work you do, that will be stored in the form of potential energy of the spring. So can I say in this particular case, guys, work done by spring force or conservative force, spring force is also conservative force, is equal to negative of change in potential energy. Absolutely, sir. Now take this over here. So I would say change in potential energy is going to be, sir, work done by this conservative force. So this delta U is equal to minus. Now tell me, what is the work done by spring force? I have already told you what is the work done by spring force. That is minus 1 divided by 2. That is minus 1 divided by 2k. And then we say x final square minus x initial square. This is the work done that we have already studied. Okay. Now, my dear NEET aspirants, what I can say, this change in potential energy will be U final minus U initial is equal to U final minus U initial is equal to. So minus into minus will be plus 1 divided by 2 k. Now this x final is how much? That is x. X initial is how much? That is 0. So this will be x square. This is x square. Now initially at this point at mean position we consider potential energy 0 because mean position is the reference line. So this potential energy is 0. You'll be like final potential energy in this particular case, it is going to be 1 by 2 kx square. This is the potential energy stored in the spring. This is the potential energy stored in the spring. 1 by 2 kx square. This is the potential energy stored in the spring. Okay. Okay. Now, my dear NEET aspirants, also, we say F is equal to K times of X. So can you tell me in this particular case, what can I write X? X in this particular case, how can I write X? So X will be in this particular case, F divided by K. Now put it over here. So potential energy is going to be 1 by 2. Then we say K. And instead of this X, I can write F square divided by K square. Now this K and square will be cancelled. This K and square will be cancelled. So U will be equals to F square divided by 2K. You can write the spring potential energy like this also in terms of F and K also. Okay. Now, my dear NEET aspirants, listen to me very carefully. Listen to me very carefully. You got two equations. U is equal to 1 by 2 kx square. U is equal to F square divided by 2k. Now, if I say what is the relation between U and K, we say if X is constant, elongation in case of a spring, if you have two springs, if they say elongation in two springs is constant, same. So I can say this U is proportional to K. And my dear NEET aspirants, we say if force is constant, in that case, U is inversely proportional to K. I hope you got the crystal clear feel of this. I hope you got the crystal clear feel of this. I hope you got the crystal clear feel of this. Okay. Now take a look, guys. The potential energy of a long spring when stretched by 2 centimeters is U. You have a long spring, its potential energy is I would say 2. Okay. If the spring is stretched by 8 centimeters, the potential energy in it will be, see guys, in this particular case, it says that you have a spring. If you elongate this spring by 2 centimeters, we say x1 is given as 2 centimeters. Okay. So potential energy U1 is given as U. If the same spring is elongated x2, if it is elongated by 8 centimeters, you are supposed to find potential energy this. Now tell me, if the spring is same, if the spring is same, you tell me, my dear friends, U is equal to 1 by 2 kx square. If the spring is same, in both cases spring is same, so can I say in that case K will be constant? Yes, whatever is the value of K here, same will be here. So in that particular case, u is proportional to x square. In that particular case, u is proportional to x square. So can I say, sir, u1 divided by u2 will come out to be, that is x1 divided by x2, its whole square. Now, what is the value of u1? What is the value of u1? That is u. What is the value of u2? That is u2 is equal to x1 by x2. So this is 2 divided by 8. x1 is 2, x2 is 8. Whole square. 2 ones are 2, 4s are 8. So u divided by u2 is equal to 4 square is 1 divided by 16. So take it over there. So u2 will come out to be 16u. So u2 is going to be 16u. Okay. Okay. Is that clear, my dear NEET aspirants? Force constant K1 and K2 of two springs are in the ratio of, so here K1 and K2 are given. That is 5 divided by 4. 5 is to 4. They are stretched by the same length. Okay. So in this particular case, X is constant. So there are two springs. Ratio of K1 by K2 is 5 by 4. And they are stretched by same length. So you have stretched them by same length. The potential energy of first spring, U1, is given as 25 joules. Then the potential energy of the second spring is U2, you guys are supposed to find out. Now tell me, if X is same, if X is constant, so U is directly proportional to K. Just one liner question. We say here, if X is constant, in that particular case, U is proportional to K. So what will you say? U1 divided by U2 is equal to K1 divided by K2. Now, U1 is 25. U2 is that you are supposed to find out. K1 is 5 divided by, I would say, 4. 5 ones are 5, 5s are 25. 5 into 4 is 20. So U2 will come out to be, that is 20 joules. Conservation of mechanical energy. Conservation of mechanical energy. Okay. जी नहीं, आप बताओ आप कौन हो एग्जैक्टली थोड़ा सा बताओ मुझे डिस्क्रिप्शन अपना। तारिक साहब, कौन हुज़ैफ? हु हुज़ैफ? Okay, 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 okay. Now guys, take a look. Now guys, take a look. Conservation of mechanical energy. I want you guys to understand this particular point. I want you guys to understand this particular point. See, when it comes to the conservation of mechanical energy, it means total energy initially is equal to total energy finally. I'll make you understand. That means kinetic energy, total energy means kinetic energy initially, plus I would say potential energy initially. It will be equals to kinetic energy finally, plus I would say potential energy finally. That's what I can say. This is what we call the conservation of mechanical energy. This is what we call the conservation of mechanical energy. It will take us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Only 10 slides we have. How much time it is going to take? 15 to 20 minutes maximum. So this is conservation of mechanical energy. Now guys, see, let's suppose if you release an object from this particular height. So means releasing the object is initial velocity 0. So when it is at rest at topmost point, we consider its kinetic energy as 0. We consider its kinetic energy as 0. Okay. Now, my dear NEET aspirants, initially, I would say its velocity, initial velocity, it has 0. So its kinetic energy initially is 0. Now, my dear NEET aspirants, what is the potential energy at top? Sir, kinetic energy initially is 0, potential energy initially is mg into h. When you release this object, it will come and it will strike this. It will strike this. So when it strikes this surface over here, kinetic energy in this particular case will be 1 divided by 2 mv square maximum. And potential energy on the surface is 0 because on the surface we consider it a reference line. So on the surface we say potential energy is 0, kinetic energy is maximum. So here this is 0 and this is maximum. And in this particular case, this is maximum. Now you see, can I say in this particular case, total energy initially, let's suppose if it has 10 joules of energy, so that 10 joules is in the potential form. When it is released, when it falls down, it gains motion. So that 10 joule is converted to the kinetic energy, but overall energy remains conserved. Total energy initially is equal to total energy finally. I believe this is crystalline clear. Now, my dear NEET aspirants, listen to me very carefully. We have recently studied, as we know, work, energy, pure. What does that say? That says work done by all the forces is equal to change in kinetic energy. Let me give you the proof of this also. So work done by all the forces means work done by conservative force plus work done by non-conservative force. Okay. Plus work done by external force. It is equal to change in kinetic energy, that is a delta Ke. Now in this particular case, conservative force means friction. I am saying when you consider this situation, friction is 0. We consider air resistance as 0. So work done by non-conservative force in this particular case is 0. Sir, work done by external force. There is no external force acting over here. That is 0. So what is work done by conservative force? Sir, we have studied this is negative of change in potential energy is equal to, I would say, change in kinetic energy. Absolutely, sir. Now, guys, what I can say in this particular case is, listen to me very carefully. Take it over here, or you can say this is negative of U final minus, I would say, U initial is equal to, sir, this is kinetic energy final minus kinetic energy initial. Okay. Now, this will become minus final potential energy plus initial kinetic energy is equal to final kinetic energy minus initial kinetic energy. Yes, sir. Now, guys, do one thing, take this final over here, take this initial over here. So when you take this initial over here, here it is minus, it will become plus. So kinetic energy initially plus potential energy initially. It is going to be kinetic energy finally plus, I would say, potential energy finally. So this is what we say, total energy initially is equal to total energy finally. So that's what I was saying, conservation of mechanical energy. Okay. So when work done by non-conservative force is zero, in that particular case, my dear NEET aspirants, we say total energy initially is equal to total energy finally. This is what we call the conservation of energy. Like, take a look in this particular case. A particle is released from height s. There is an object which is released from height s. Okay. So there is an object which is released from height s. There is an object which is released from height s. Okay. Okay. So this is s height. This is s height. It's at certain height, its kinetic energy is 3 times its potential energy. Guys, see, let's suppose at this height h, its kinetic energy becomes 3 times potential energy. Okay? Yes. And if I say initially, what is the potential energy initially? Sir, this is potential energy initially. It has maximum. So 3 times at certain height, 3 times its potential energy. The height from the surface of the earth, the height from the surface of the earth, the height from the surface of the earth at the speed of the particle at that instant will be, you have to find the height of this point and speed at this point. That is the question. You have to find the height at this point and speed at this point. This is a very, very good question in this particular case. Okay, height at this point and speed at this point. Now, my dear NEET aspirants, in this particular case, what I want you guys to do is, we say use conservation of mechanical energy. That is total energy initially is equal to total energy finally. That is kinetic energy initially plus potential energy initially will be equals to kinetic energy finally plus potential energy finally. Kinetic energy initially plus potential energy finally. Now, my dear NEET aspirants, in this particular case, what is kinetic energy initially? It is at rest, so 0 plus potential energy initially is equal to kinetic energy finally. So from here to here, you are applying this. From here to here, you are applying this. So I would say that is 3 times of potential energy plus. So potential energy finally, that is potential energy. Now potential energy initially, my dear NEET aspirants, sir, what is the potential energy at this point? That is mg into height is s is equal to. Now, my dear NEET aspirants, this is 3 times, this is 4 times potential energy. Okay, 4 times potential energy. So you will be saying, sir, what is the potential energy of this point? Consider this as height. Don't say this one, this. So this will be mgs is equal to 4 times of mg into h. Because at this point, potential energy is going to be mg into h because height is h. Now guys, mmgg, so h will come out to be s divided by 4. So this height in this particular case is going to be s divided by 4. It is s divided by 4. Okay, it is s by 4. Now, boys and girls, we have to find what is the speed at this point. Listen to me very carefully. We say as, when it comes to the kinetic energy at this particular point, we say it is 3 times of potential energy. Kinetic energy is 3 times of potential energy. What will you say? Kinetic energy is 1 by 2 mv square is equal to 3 times of potential energy at this particular point is, that is mg into h. Instead of h, I can write s divided by 4 because potential energy at this point is mg into h. Now guys, what I can say in this case over here, m and m will be cancelled. 2 1s are 2 2s are 4. Okay. So v square is equal to 3gs divided by 4. Take this root over here. So it is going to be under root of 3gs divided by 4. This came out to be the velocity in this case. Okay. So 3 by 4 gs and then we say whole root. This question I'm giving you as homework. Please do check it from your end. Its solution is mentioned over here. Its solution is mentioned over here. Now we have the last topic and it will take us 5 more minutes and we are done. That is power. What does power actually mean? We say this person has a lot of power. What does lot of power actually mean? That means he has a good capability of doing work. That means he has a good capability of doing work. Okay? That means he has a good capability of doing work. Okay? Now, my dear NEET aspirants, what I'm trying to say in this particular case is, power. We say it is defined as the rate of doing work. It is defined as the rate of doing work. With what rate a machine is doing work, that is what we call power. So he is doing work very quickly, power is more. Okay, it is the rate of doing work. If we have two cars with less horsepower and more horsepower, what does that mean? It means one is capable of doing more work as compared to other in the same time. One is capable of doing more work as compared to other in the same time. So it means one has more power as compared to other. So power is the rate at which work is being done. If the work is being done very fastly, we say power is more. Now, we say power is simply, that is, work done upon time taken. Work done upon time taken. And if I say this power, that is work done. Work done is delta W and time taken is delta T. Delta W and time taken is delta T. Now, my dear NEET aspirants, this is the power. Now we say as, can I write it like this also? We say this power is, sir, work done, total work done means, how do we write the work done, sir? Kinetic energy, change in kinetic energy. So it is delta Ke divided by delta T also. We can write the formula of power like this also. Okay. Delta Ke divided by delta T. Now, my dear NEET aspirants, we can further say in this particular case, this is the average power we can define. So we say when it comes to the instantaneous power, instantaneous power, we can define it like this. That is simply dW divided by dt. It is simple, guys. If you are doing work from this time to this time, so means that is average power. So at a particular instant, how much work is being done? So I'll write over here, it is the work done at a particular instant. It is the work done at a particular instant. Okay. So you can write it like this. Even you can say, sir, this instantaneous power is simply, instead of dW, you can say small change in kinetic energy upon small change in time. You can write it like this also, my dear NEET aspirants. Okay. Now, can I further make one more equation over here? Sir, this power in this particular case is dW by dt. Instead of dW, I can write F ds divided by, I can say dt. So you can say this power will be F ds divided by dt. It is F dot V because work is F dot ds. So ds divided by dt is V. So F dot V. So dot product of power, force and velocity. So power is simply force dot velocity, dot product of force and velocity is power. It is power. Okay. It is power. And even I can say this power is also, that is F dot V is FV cos of theta, because A dot B is AB cos theta. So F dot V is FV cos theta, FV cos theta. As simple as that. As simple as that. Okay. As simple as that. Now, my dear NEET aspirants, slope in case of work time graph. What is the slope over here? If you say, sir, slope is going to be tan theta, and tan theta is perpendicular by base. Perpendicular is dw and base is dt. What is the value of dw by dt? That is I would say power. We recently studied. So can I say in this particular case, slope of work time graph gives us power. So from now onwards, if work versus time graph is given, you are supposed to find power. You will find what? You'll find what? Slope. Now, if I say power versus time graph is this, in this particular case, if I say what is the value of this area? Area is simply integration of whatever is on x-axis, and then we say dt, integration of p dt. Now, integration of p dt, guys, see, we say power is dw divided by dt. Take this dt over here. So dw will be p dt. Now integrate both sides. So integration of dw is total work done. It will be integration of p dt. Now call this equation second and call this equation first. So integration of p dt simply means work done. So can I say from first and second? From first and second, you can say this area is going to give you work done. You can say this area, it is going to give you the work done. As simple as that. Okay. So work done means area of which graph? PT graph. Area of PT graph. For a variable mass system. Guys, when it comes to the variable mass system means where mass of the system is changing. Where mass of the system is changing. Okay. See guys. We have studied Newton's second law. F is equal to dp divided by dt. What is the value of momentum? F is equal to d divided by dt of momentum means mass into velocity. My dear NEET aspirants, if I say if velocity is constant and mass is variable, means an object is having the constant velocity and variable mass. So take this velocity out. And differentiation will be for mass, dm divided by dt. This is going to be the force in that particular case. Yes, this is going to be the force in that particular case. Now, my dear NEET aspirants, we can say as power is simply, we recently studied that is F dot V. Okay. So power is simply, I can say FV cos of theta. FV cos of theta. Now tell me, this power I can write over here. Instead of F, I can write V dm divided by dt into V, and then we say cos of theta. Now V into V is V square. So power will be V square dm divided by dt, and then we say cos of theta. Now, my dear NEET aspirants, if I say theta is 0, so cos 0 is 1, power will be V square, then dm divided by dt. So this is the power in that particular case. This is how we can find the power in that particular case where mass is varying, where mass is changing. So these are all the formulas of the power. Now, first question was asked in NEET 2023. So it is given as a particle of mass, a particle with a velocity. Velocity is given as 5i cap minus 3j cap plus 6k cap. Okay. Horizontally, under the action of force in this particular case is given as, this is force given as, that is 10i cap plus 10j cap. Okay. And then we say plus 20k cap, plus 20k cap. The instantaneous power supplied to the particle. Instantaneous power supplied to the particle. Power in this particular case is going to be F dot V. Dot product of these two. So power is going to be, dot product means 5 into 10 is 50 minus 3 into 10 is 30. Dot product means simply multiply this with this, this with this, this with this. 6 into 20. Okay, that is going to be 120. Okay, check whatever the answer in this particular case is. Okay, this I am giving you as homework. This I am giving you as homework. This is homework and its answer is mentioned. Please do check it from your end. This is homework. Its answer is also mentioned. This is homework. Its answer is also mentioned. And then we are done with this particular chapter. I would say done and dusted. Okay. Take care. Bye-bye. And do let me know in the comments how was the session.